Ben, do you have any announcements that you want to bring to the team's attention before we get started?
Yeah, I'll just say as we go along, I'll be creating those breakout rooms, and I have noticed just a few have been taking advantage of those breakout rooms. Those are designed for you to meet with your research teams, and then we'll also have one for seed registration as well. So as we go along, I'll be creating those, and then I'll open those up as toward the end of our sessions today. And I've noticed though that if no one's in there, it shuts down after 40 minutes. So if you are going to take advantage of that, it's probably better to take advantage of that sooner than later after our sessions today.
You haven't received any complaints that people couldn't get in, have you?
Not yet.
So you're probably not using them.
Yeah.
Nat, what about you? Do you have any announcements you'd like to bring to the team?
No, I think we're good. Yeah, no necessary announcements here. Thank you.
Great. We'll wait just one more minute, Bruce, and then we will get started.
Okay.
Hamaker and his team from Niger and Senegal on their project on expanding markets for sorghum and millet farmers through strengthening of women and youth processors and nutrition-based promotion of products. Bruce, I think you get the award for having the longest title. So I'd like to give a few words there. So Bruce, please go ahead.
Thank you, Tim. Thanks. And it's good to be with you all today. I'm going to, just to give you an overview, we have, I have 43 slides. I'm going to go through fairly quickly because certainly want to leave a good amount of time for Q&A, but then also Mustafa does have the group there, though we're not going to go through introductions like last year. I think it took too long, but to have two of the women partners there, processors, to give short 5-minute, we've arranged 5-minute presentations or just talks at the end of this. So I'm going to move fairly quickly then. Whoops, let's see, wait a second. Okay, the team is Mustafa Musa at INRAN Niger, is the head of the program there, and also the country coordinator. Sheikh Dai is our head at ITA, Institute of Food Technology in Senegal, in Dakar. Both Mustafa and Sheikh received their PhDs from Purdue University, Mustafa from myself, Sheikh through Mario Ferruzzi. I'm at Purdue, and Mario Ferruzzi is now at Arkansas Children's, probably I got the wording wrong on that, Mario, but Nutrition Center. It's one of the USDA Children Nutrition Research Centers, one of 2 in the United States. And Mario's the I want to say, new director. You've been there some months now. The INRAN team consists of quickly, Mokhtar is a food technologist student, Yaye Hama, economist, Yagana Kafugu, the nutritionist, Hamza Lamso in communications, Lawal's a data analyst. There are a variety of urban processors and rural processors. You can see them on the screen, and you'll get to meet again a few of them later. The ITA team also has Jibril Traore and Falou Sarr. Our partnering organization, and it's a big one really in Niger, is the McKnight Foundation. Tim mentioned the McKnight Foundation the first day. They're a really important partner, and we work together in the incubation area of processors in Niger. Also, we have the Food Processing and Post-Harvest Innovation Lab. It's centered here at Purdue, and we're a partner. The SMIL project, this project's a partner with FPIL. The general project structure, as this is over time, is we've developed a supporting system for existing and new processors to incubate them. And we call that the Hub and Spoke Food Innovation Center, or centers. This supports urban entrepreneurs and rural women's associations, processors with technologies, formulations, processes, science-based nutrition improvements to products. We've spent a lot of time, the groups there and the project, on developing new formulations, and those that I talk about and that you see have really come through the program. And these are also consumer and in some cases market tested. The idea is that processors will grow markets for sorghum and millet, and the other part of it is that nutritious foods, nutrient fortified foods, will make their way into consumers, mouths and improve their nutritional status. We call that market-led nutrition because it's really through processors and through the market. So in Niger, the 2021-2022 SMIL activities focus on rural food processing, and I particularly want to spend a few minutes talking about geographical expansion of the rural spokes that we have in this hub and spoke system into what we call secondary and tertiary spokes. In the urban entrepreneur food processor area, there's been support and further training in the last year and an increase in branded products and product sales. There's been in this phase a focus on youth and women entrepreneurism, and I'll talk a little bit about that, incubation of youth in particular, and women has been throughout the project. And then screening of new millet and sorghum varieties in Niger. I think I'll skip that. So let me just go right to the slides with the explanation. So this is something that I think is pretty neat and has happened in the last year. It's amplified in the last year. So if you remember before, this hub and spoke system consists of the hub at the inland. There's a very nice processing center. It's fairly new. It was opened within, I think, the last part of phase 1 of SMIL. It was funded through the Niger government, and it contains processing equipment. It contains training rooms. It has space for processors to come in and work there, and urban ones even to work and process foods and test markets. In the rural context, these blue circles are primary spokes that were set up now probably about 7 or 8 years ago with assistance from the McKnight or partnership with the McKnight Foundation. And in recent years, what we had seen, even towards the end of phase 1, was that these were expanding, that training was expanding and processing was expanding out of these rural spokes. Each of these rural spokes contains about, or comprises about, say, 30 to 40 women in each association. And the women had taken it under their own initiative to train other women in peripheral villages and communities. So in phase 2, with assistance, partnership with McKnight Foundation, we have provided some formal training to what we call secondary spokes. Those are in the green, and those secondary spokes are geographically located, of course, nearby to and peripheral to the primary spokes. And what has happened, and really was part of the planning, but it's happened in a kind of organic way, is that that training has then expanded into tertiary spokes. Those tertiary spokes are a few women in villages that have interest in processing. They are brought in by the secondary primary spoke facilities and trained, and even provided some basic equipment, not even from the the funds from the project, but from funds from profits that these units are making, the primary and secondary spokes. So you can see, I'm not going to go through all the names, but in 2 different locations in Falwell and Gadania, and also Tara to the west, in the west of Niger, there have been these formation of these tertiary spokes. And I have some data in the next slides on that. There also, through the McKnight Foundation, there's been activities in Burkina Faso. There are now 2 rural spokes there and 1 in Mali. And really with the hub is still back in, the main hub is back at INRAN. So here's a training of the secondary and tertiary spokes. There are some other information about that rural hub and spoke system. There are about 35 weekly rural markets, 20 community health centers are affiliated with the spoke food innovation centers. About 20 varieties have been tested through the McKnight Foundation project through a participatory selection approach that some of them are used in the different formulations. There are 10 locally accessible fortified flour formulas that have been co-created, tested, marketed to benefit several hundred of vulnerable groups, including malnourished children, and about 500 women and youth have been empowered, including 10 students through this system. And this is in the last year. So here's sales data of the primary in blue spokes, secondary in orange, and tertiary in gray. And the interesting thing is that combined, the tertiary and secondary spokes now have product sales. This is in dollars, US dollars, have sales that together comprise about the same or a little more than the primary spokes. In different locations, here are primary spokes, Falwell, Gadania, Sorghum, and Tara, and right here are 2 secondary spokes, this Sais, Sabua, and Zindagore. Here are different products that they produce, they process and produce and sell. And I've put a little red circle with Mustafa's help, of course, on products that we consider to be fortified. Now here's the fortified flour in gray. These are ones that contain food-to-food fortificants like a baobab, moringa, and so forth. But the other ones at least have protein fortification and sometimes some additional fortificant for micronutrients. So maybe not complete, but still they are considered and sold and bought as nutritious products. I won't go through each one of those. Just to say also that Tara is a town located in southwestern Niger near the Burkina Faso border. And this secondary spoke, Zindagore, is one that's right on the border with Burkina Faso, and with security as it is, problems that exist today in the Burkina Mali border area. This is an area that the team from INRAN can't even go to right now, but it's a good thing to see that there is activity there and they are selling into those rural markets and having some sales. This is some profit data. We need to do some more work on profit data before the annual report or for the annual report next month in April. But here's at least a snapshot of a couple from Gadania near Maradi, from Sorghum, these are all in the Maradi area actually. And these are in US dollars too. So it's about $500 of profit in those 2 towns or communities, sort of large villages. And this Sabua is, as I said, is a new secondary spoke, but it's an interesting one. It has big sales. It had, there's a lot of energy there. It's right on the Nigerian border. And from Mustafa's point of view, the larger profit perhaps has to do with some cheaper goods coming, basic, products, ingredients and so forth coming over from Nigeria, but that needs to be confirmed. Here are different products in the different locations, different spokes, but just to show some natural fortificants that are being used: moringa, baobab, pumpkin, carrot. That's for micronutrient fortification. Here are branded products, sorghum and millet, sold in the rural markets by the women's groups. And to say also, I mentioned it last year, we have a project that really is patterned off of this hub and spoke model in Niger, in East Africa. It's funded by the Rockefeller Foundation. It's done next month. It was a 2.5-year project. Due to COVID, it was extended an extra year. It's in Arusha, Tanzania, and Nairobi, Kenya. It's in the maize and mango value chains. And there's a lot of good success there in the maize value chain. In the case of maize in Arusha, there's 3 rural spokes. They all have sales. 2 at this point are profitable. And there's an entrepreneur in Arusha itself too, for an urban entrepreneur. And in Nairobi, there's a lot of good success around that mango processing and the hub and spoke system towards urban processors using mango, dried mango powder, that kind of thing as ingredients and for direct sales. But it's an example of not just in cereals, but can be used in for other food areas. For the urban Niger project, there's been a number of activities in the last year. There's been some work done on making fortified blends. These are instant, these are all instant down to the roasted products. These are extruded instant products. These are non-fortified ones that have been worked on in the past. And this last year and the year previous to this, there's been work, and these have been finished. There's been consumer preference studies done on these that I'm not going to present, but they will be in the annual report. So millet co-extruded with peanut, a millet extruded into a fortified with different fortificants, and sorghum extruded with different fortificants. And then there's also been work done on producing roasted millet and sorghum fortified flours for urban sales. And the roasting process is also used, I didn't mention it, but in the rural spokes and the rural, for the rural processors, they use a roasting process for the fortified flour products. And roasting, it's not instant, but it is a faster cooking product. There are a number of branded, there's been emphasis in the last year plus on branding products, and Madame Liman in the largest enterprise, ETC, has processing equipment that she obtained through UK aid that was facilitated through the SMIL project. That happened about 3 years ago. And she's nicely letting other processors use that and brand their products. So here's some of the branding of products in the urban market. And there's production data, and in the last year, there's been good amount of sales. Here's in a graph. These are in dollars. So ETC in Mustafa, I just looked at this, but that's from September 2021 to February 2022. And ETC, that's around $300,000+. And I guess going back to this table, well, just to say there's about, no, it's in this table, about 80 tons of product with all the 10 enterprises combined, about 80 tons of product produced per month, which is a quite good amount and is an increase over previous years. Those are average number of different products produced by each of the different enterprises. In the youth entrepreneurism area, there's been training at the NRAN Hub Processing Innovation Center and the use of the hub facilities to produce products. So the youth entrepreneurs that are being trained are using that facility and selling products, beginning to sell products out into the marketplace as a way to test the market and start their businesses. 20 youth have been trained and backstopped in grain processing and fortification. And here are some branded products from the youth and women processors. Mustafa, I probably won't do this justice, but Lutgar, this connects with your project, and Mustafa sent this last night. But what I can see from this is that that they did a consumer panel, a sensory panel, looking at acceptability of tuo, the thick porridge that's eaten in Niger from millet varieties treated with different treatments. And the blue one is the local variety that is treated with the, I believe, the organic manure. Mustafa, you will have to, it wasn't clear to me totally.
Yeah, exactly.
Why don't you say a few words about it? Sorry about
okay.
that.
Okay, thank you, Bruce. So this is just a sensory acceptability test we did as part of the synergic work we are having with Puma Gaskia and also Moriban, because on those sites we have activities on seed ball. So the treatment were on millet grain varieties, and Oga was used. Oga is human urine that was developed through Magnite project, and you have the seed ball by using ash and the composting, and also the NPK fertilizer, that is the green one, and the organic in blue. So all the orange is from left to right. So you have Oga, seed ball, ash, the compost, and then you have the NPK. And you can see from the box plot that the consumer have more preference for the one that are treated with those local innovative technology compared to the fertilizer food. So which is, I think, is something very interesting as a result to share with the group.
Thank you, Mustafa. We will be conducting a nutrition study in the summer and fall of this year. And I'm going to turn this over to Mario. He and I have been discussing with Mustafa a study design that's different from what we had before. We've not been able to do that nutrition intervention study, mainly due to COVID and security problems in Niger. But we're excited about this project, and I would just say that what it does is it's a survey study on diet assessment and gets market information also, and on a large group of participants, and the purpose is to understand in communities where we have those rural spokes and their sales of fortified products versus a community that does not have that, what's the potential nutritional impact of selling those kind of fortified products into those communities, and looking at scenarios that that can create nutritional impact. I don't, maybe that's not said right, but what does it take, outside of existing sales to create the kind of nutritional impact that we are looking at from the market, from this market-led nutrition perspective? Mario, do you want to?
Sure. So thanks, Bruce. And as Bruce said, this is really a tact, if you will, that we're making in the sense of the challenges we've had in terms of getting true clinical work off the ground in Niger, and learning from experiences that I'd say we've been doing through the Food Process Innovation Lab, where we're doing something very similar in an urban part of Dakar by introducing products, collecting sales and market data, but at the same time administering diet assessment questionnaires and getting an opportunity to look at nutrient intake in certain populations. We're able to do some assessment and modeling, if you will, about the impact, at least to nutrient availability, that some of these products would have if they're introduced. Of course, it does not take into account all the other factors that impact nutritional status, but this is the one that we control relative to the food. And it is also something that, for those of you in the nutrition side, know this type of assessment and modeling is often used as we develop guidance, at least for the food side of the system. So the way we were looking at this is to piggyback on 3 of the rural incubation spokes that have been highly successful and have contributed to an improved food environment, we believe, over the years by introducing these nutrient fortified foods. And we want to test the hypothesis that introduction of these food-to-food fortified products developed both through SMIL and through FPIL as well, but the concept and formulation, that is, but this is truly SMIL in that regard, that they've contributed to that by showing improvements in adopters of the product in terms of diet quality. And in this case, we're really looking at whole family and in particular children. We're going to refine down the age based on what we're learning and the quality of the data from Dakar. But what we're looking at is the 3 areas, Caldwell and Maradi, in those areas where we're looking, those incubation spokes, to leverage 600 consumers of food-to-food formulated products in these villages that have been now for several years, if you will, with the presence of these products and the presence of the incubation center itself as part of the communication of these products. We're also going to identify 600 non-consumers of the products in the same villages. So the incubation center is there, but they're not buying and consuming those products. And we will do a diet assessment, if you will, to estimate nutrient intake and gaps in their nutritional status. We will also try to identify, and this is where Mustafa has been already working, to identify village communities that are similar to the ones we have incubation center, the spokes, but currently do not have one, so that we can get a dynamic of what this looks like without the incubation center or the products. And the reason for this is, knowing we would have taken this tact at the initiation of the project, we would have had baseline data in these incubation center spokes, but because we're adjusting to this, we need to have a comparator, which is a village without. So the outcomes of this is we hope to get a good metric of diet quality, and then hopefully get an indication of how that's been impacted, or how different it might be in villages, I should say, that have these incubation center spokes and have access to food-to-food fortified flours. This also has the dimension of perhaps a little bit of some of those villages may and may not have access to fortified products through health centers. We'll be looking at that dynamic as well. We also then can take those data and then ask about sales, right? So that's understanding if we want to impact, if we increase and perhaps provide 5% penetration of these products or 10% penetration to target groups, children, for example, how does that impact their nutrient availability and intake? So these types of swaps and modeling studies can be used to give us an idea of where we need to reach in terms of sales to actually have impact in nutrient availability. Bruce, yeah, you can go to the next slide. So the secondary hypothesis is what I think Bruce has kind of already alluded to, which is how far out is the reach of these incubation spokes in the rural communities? And, you know, what impact do they have? And in our case, it's the impact on nutrition. So by looking at the influence of the difference between the primary spokes that we have and then the secondary spokes, where we might be able to add additional questionnaires, food frequency of consumption, child-specific consumption of millet forages, and diet diversity questionnaires, we can get to those same questions, but now further out from the incubation center primary spoke. And we get to find out more about how those secondary spokes may be delivering the message or not in the same way. So we're going to center in on one. Right now it says Falwell, but Mustafa and Bruce and I are going to talk about which one is best. This was just a placeholder for that. But again, 600 consumers in villages with secondary spokes and 600 non-consumers in those villages with secondary spokes. Adding that to the data from the primary hypothesis, we can get some insight into how improvements can be driven through these secondary spokes and perhaps even further out. Do these differ based on access to health centers? Some of these secondary spokes have access to health centers, some don't. So we'll hopefully be able to parse out some of that data to understand if these incubation centers are working in concert with or improving what's happening at the health centers in terms of access to fortified flours. And ultimately, we really want to understand the geographical range of impact from the primary spokes. So back to planning targets for sales of products, this also gives us an idea of where to place spokes if we're going to enhance the impact across a broader geographical area. So I'll stop there, Bruce.
Thanks, Mario. That's perfect. And we want to work at Falwell. Probably will be a good site because the tertiary spokes there have sort of taken off, so it can expand out into that level. Senegal. Three different things I want to talk about rather quickly: sensory science laboratory, products with commercialization potential, and again, incubation of youth and women entrepreneurs, which is one of the activities in both countries for phase 2 SMIL in our project. The sensory, there's a really beautiful sensory facility has been put together at ITA. It's been mentioned, I think, the first day, and we look at it to be a really resource center for the region. And it's the first of this kind of sensory center that's been put together that will have the abilities to do all kinds of different sensory testing, including trained sensory panels. We're in talks right now with a group, well, CRAD, not a group, but CRAD in Montpellier, France, about doing a training activity for one of the scientists there who will be running the sensory center on a more full-time basis. We're in talks right now with CRAD about that. That person will go up to CRAD. Perhaps there will be further training after that. And then there will be a launch of this facility. We're looking at probably July, and we'll let certainly you at the SMIL headquarters know about that as we get more information.
I didn't get that. Could you try again?
Sorry about that. The group there at ITA has done varietal testing of millet lines with ISRA, with the production program, identified a good millet variety here outlined in red that has elevated iron content to 11.6, which is quite good for a kind of biofortified millet variety, which there's variation in millet and race and varietal lines of the micronutrients, particularly iron. There's using this kind of hub spoke incubation kind of model that we have that's functioning there at ITA also. There's been incubation of some enterprises with linkage to another project, an African Development Bank project, where there's potential to get financial loans through the incubation process at ITA. Like INRAN, as I spoke, in this case, the processors are being trained in the center, and they use the equipment and they produce product, and then they test the market. So there's that activity that's been going on in the last year. There's been a further and probably the final testing of a couple products, Instant Arao. It's using extruded flour. It's a novel kind of product we talked about before. Don't need to talk about it here, only to say that sensory evaluation shows it has very good acceptability. People really like it. There's two different enterprises in Dakar that are very interested. We're working to try to get them to use it in this last year. That's what I can say about that. And also about a fermented economic couscous. It's been going on for a long time, though to say that there now is an isolated strain of lactobacillus that is being used for more consistent or for consistent product, fermented products, kind of a soured couscous product that's really liked in that market. And there's a lot of interest from these same two processors, and we'll work to try to get that out into the marketplace in this last year. There's new products. Here's in the youth entrepreneur incubation. Here are some new products that they are producing and packaging there at ITA. So just not to go into detail, but just to show you that there's a number of those that have been developed. And thank you very much. And I believe, Tim, I hope we have time for just 5 minutes for two different of the processors there in Niger, but you say if you'd rather go to questions first.
No, we've got plenty of time, Bruce. We're scheduled to start the next presentation at about 15 after the hour. So you've got a good half an hour.
Okay, thank you. So Mustafa, we had talked about Hajo and Madame Liman, I believe, but you take it over.
Actually, we have Hajo, Ure, Hajara from the secondary spoke of Sai Sabwa. And we have also Madame Liman, who will also talk about the urban entrepreneur. And in addition to that, we have two videos we had wanted to share if the time allow. One is 3 minutes, the other one is 5 minutes. If not, we can just post them for people to see.
Mustafa, we might go to the, we might wait to the end for those, is my thinking, and to not spend more than 10 minutes with the different, in total with the different people, so that there's plenty of time for questions. I don't know, Tim, if you wanted to say something.
I prefer to have some human interaction, and we can post those videos. Please, Mustafa, we can put those on the website with all the other videos. So let's proceed that way, and then we can get into question and answer.
Sounds good.
Okay.
Bonsoir, c'est Hajo.
Bonsoir.
Bonsoir.
Hello,
de Falo-
Hajo. Bonsoir.
Oui. Du village de Faloal. Et après notre formation, le centre a mis en place un comité de gestion du centre. Le comité de gestion, c'est lui qui fait le suivi, faire des requêtes pour les transformatrices. Après la formation, on a transformé plus de 300 membres dans 10 villages.
300.
300 membres
members,
dans 10 villages.
6 villages.
Mustafa, it'll be best if you're going to translate, right?
Okay.
C'est dans l'appui qu'on est en train d'appuyer le premier centre d'incubation. C'est dans ce fonds qu'on a pu créer, qu'on a pu appuyer les centres tertiaires.
So he's just explaining that the way they organize from the secondary spot, the primary and secondary spot, that they train and support the tertiary spot, the tertiary spot.
Il y a aussi l'accord de, comment dirais-je, les agents de santé. Il y a l'appui de, comment dirais-je, les radios communautaires. On a une radio communautaire pour la publication. On a l'appui des autorités locales.
So she's just saying that they are getting support from the local authority and also the health centers to do the training, because they train like 300 women around that place, and most of them are in the tertiary spot. And also they are using their radio, rural radio, to make a lot of promotion about their product. So all those are helping them.
Il y a aussi un produit de qualité.
And they have their product is of good quality in the village.
Merci.
Merci, merci.
Okay. Bonjour. Donc, moi, c'est Houré, Union Hanevetera. Donc, on a, après le centre primaire, on a un centre secondaire. Donc, ici, qui est à Zindogori, on a formé 96 membres femmes. Donc, le centre est bien équipé. Les produits sont bien aimés par la population. Il y a la collaboration avec le centre de santé de Tera, Zindogori et Yagourou. On a une collaboration avec les radios communautaires qui nous font les publicités, les sensibilisations. Il y a les relations avec les partenaires, les autorités, telles que la mairie, la préfecture et les autres partenaires comme il y a le REPEPA, l'Afrique verte et ONIFAM. Donc, les produits sont bien vendus cette année, surtout avec la sécurité qui est à Terra. Donc, il y a beaucoup de population cette année chez nous. Donc, vraiment, les produits sont bien vendus là-bas. Et donc, il y a la réduction de la malnutrition. Vraiment que la malnutrition est beaucoup réduite. Il y a l'augmentation des revenus pour les femmes. Donc, il y a la création des emplois. Donc, il y a la participation des femmes aux grands événements tels que les foires. Donc, toutes les... nous participons des centres à beaucoup d'événements au Niger et même parfois à l'extérieur.
So I will just summarize. Kure is from Terra, around the Burkina Faso border, is 170 kilometers from Niamey. And she said that they trained 96 women for the secondary sport, the new center they have established and they keep, and they are selling products, more especially the fortified products. And they are also getting a lot of support from the local authority, more especially the mayor, and also the province, the governor is just not governor, but small governor. So the health centers, and they are also getting partners like ONU Farm and also Africbird, and some other partners are really supporting, and also they are selling well their product. The product is helping the malnutrition in their communities, and also empowering and getting incomes for their women. And it also gives them visibility in their location, and they invite them to events that are going locally, like trade fair and some other meeting, and even sometimes they are invited outside Niger to go and participate to meeting and expose their products. Yeah, she also mentioned a very important message about the insecurity we are living. So, you know, we have multi-dimensional shocks right now in the Sahel, more especially in Niger, Burkina, and Mali. And they are very close to Burkina. So their products are helping because there are a lot of people moving from their village because of the insecurity. So they are leaving their village, and those products are being sold and helping them because they are just ready to cook. And they also, he want to give a message that they also get the Ecuador prize through the support from McKnight, and those are the union of Moriband that get it, Terra and Falwell. So she wanted to inform you about that prize. They were part of the group that helped to get that prize. She's thanking you.
Mustafa.
Yeah, so we have two. Yes, Bruce?
Yeah, I think we have just a few minutes, right?
Yeah, yes. It's just the one of the secondary spoke. She's going to talk about why they are new, and they are having this high sales of product.
Yeah.
And then Madame Liman will take 1 minute to talk about the urban processor.
Okay.
Assalamu alaikum. Assalamu alaikum. Sunana Hajara Umaru Maradi Sai Sabon. Sabon santar da muka azabara. Mun samu kayan aiki, mun samu jari, mun samu horo daban-daban ga mata na sarrafa kayan gona. Muna dage, muna kuskus, muna dakkowa, muna garin yara. Alhamdulillah muna kasuwa, muna samun riba. Dangance da riban nan da muke samu, da yawan jama'a da sati ne samdi muke yin waɗannan aiki. Amma yanzu dangance da yawan jama'a mu da sai da muke yi, muna ganin muna samun riba. Yanzu da samdi da na kuredi muke yi, muna sai da. Alhamdulillah muna samun jari. Sai muka koma muka samu dahawa mer ya daha mu, ya ga abin namu mai ci gaba ne, sannan muna sai da ce duk kasuwa mu kai kamu muna sai da dan domin mu samu karuwa. Sai likita kuma muka samu dahi ga tafasarkin mu, da yake ina zaman masu ral, muna sensibilisation cikin likita na zuwa awo da kai yara wurin allura. Ya ba mu dama ina sensibilisation cikin wannan sai da gari na yara masu samuwa cikin likita. Alhamdulillah mun samu muna sai da, kuma likita ƙauye alhamdulillahi muna samun kasuwa. Daga nan sai muka samu wannan mayar kuma na caɗuwa da tawagashi. Da ya samu labarin muna sarrafa waɗannan kayan gona sai ya zo da matan shi. Ya ina nan wurin muna ta aiki ya ga abin alhamdulillah ya ba shawa. Shi ma ce yana fatan Ubangiji Allah ya ba su wannan santar su ma kamar mu. Muna yin kayan mu ya ce mu riƙa yi muna kai suna saida mana idan su ma an sun samu wannan santar samu wannan dama. Alhamdulillah kuma gidan rediyon suna tallata mu kama an san ko suwa ne an san inda muke an san santar mu. Alhamdulillah.
So she's just talking. She's from Sai Sabwa. Her name is Hajara, and she's the president of the women there. So she said that after the equipment of their centers, they have started to they get the training spoke and they started to process like 4 products, which is they get the kua, the 45 flour, and they have also another product they call tarmahaha. It's a kind of millet flour that is enriched with some spice. So then they are selling and they get a lot of support from their mayor. We back them and gave them opportunities to expand the market. So then they,
discussion and
hello?
ለማድረግ አስቦ ነበር እና ከተመቸ ማታም ከመጣ ራት እየበላ ማውራት ይችላል።
Alemo, could you please mute your microphone?
An interference. Yeah, in Ethiopia.
Yes.
So then
አንድ ሰዓት ምናምን
hello? So,
Yeah, go ahead, Mustafa. Go ahead.
Yes, okay. So the reason is really before they were working just one day, then they noticed that they are having a lot of sales. Then they work like 2 days and then they increase the number of days and they get more support from another mayor. That the town is called Chadwa, is a neighboring town, village around their location, which also send women to be trained. And also they came, they train and they sell their product for them. And they are having also the local radio that is supporting promotion of their product. And they expand and she said they are getting a lot of profit. And now they are very, very occupied. And she's also part of the women working at the health centers. They call them a farm relay, like in terms of weighing the children, and also giving some orientation to the rural women. She's part of those women. Because of that affiliation, the health centers gave her opportunity to come and test the product. And now they are getting and buying their 45 flour and they are expanding it to other health centers and other villages. So that's the message he wanted to share with the group.
Thank you, Mustafa. Just another like 2 minutes. Yeah.
Madame Liman is just going to, okay. Madame
Yep,
Liman,
we do.
you speak in French.
Bonsoir, toute
Bonsoir.
l'équipe. Donc, oui, nous, ici à Niamey, vraiment, la transformation a pris de l'ampleur parce qu'on arrive à écouler nos produits. Et il y a beaucoup de demandes avec l'insécurité sur les farines fortifiées livrées aux déplacés. Et les farines sont fortifiées et il y a des ONG. Actuellement même, on est en train de faire une commande sur DIFA pour DIFA et Tilaberi. Et toutes les autres, malgré la cherté de la matière première, les femmes ont leur engagement. Vraiment, on remercie. Et tout ça là, c'est grâce au SMIL et au projet McKnight et les autres projets parce que c'est eux qui nous ont donné ce avant-goût que maintenant on ne va que en avant. Merci.
Yeah.
Mustafa. Merci,
Yeah,
madam.
so I think for the translation, she's just saying that they are getting a lot of sale for the sorghum and millet and other related grain-based products, more especially the fortified products. Because of the insecurity, they are getting a lot of invoice from some NGO and other humanitarian institutions. And most of the products she's now selling for those communities is in Difa and Tilaberi, where we have most of the crisis. And she said that they are having more and more demand, and they sell very well their product in also Niamey. And she's really thanking the project SMIL and also Magnite and all the related products that help them to achieve their work at this point.
Thank you very much. Merci, Madam Liman. Tim.
Okay, thank you very much, Mustafa and all of your partners there, Bruce, Mario, Shek, for your review and presentation. We're going to open up this at this time to questions from the audience. So raise your hand or put something in the chat box. And while people are volunteering for that, let me just ask a question to Mustafa and maybe the team in general. So many of these products are fortified or are being marketed as being fortified. To what extent has there been any quality control or evaluation of village produced products for their level of fortification? And I'm just concerned that many of the natural fortificants we know have limited shelf life. And I'm just concerned that we are marketing something which may not be what it's claiming to be. And that could lead to some very significant problems if any nutritional agency comes and tests that and they're just not what they claim. So tell me what you're doing to ensure that what you are claiming is actually true.
Oh, okay. So
Bruce, you want to, or you want me
Can
to, I can, either way, Mustafa, you can start.
yeah, okay, you go ahead.
We-
Go ahead.
Go ahead.
No, I
Mario.
think you make a great point, Tim, and I think part of the challenge you have when you go to the food fortification is twofold. One is the variation we know we're going to get in micronutrient levels, in particular, as our key focus, obviously, with much of the fortificants that we use that are natural are the micronutrients, iron, zinc, vitamin A, etc., protein as well. But we wrote a nice position paper, I guess, if you will, on this. And one of the things that we really want to equate this type of strategy, and we use the term food-to-food fortification, but it's really almost more akin to diet diversification, right? So you're diversifying foods that would be devoid of many of these other plant nutrient-rich or micronutrient-rich foods. The formulations that were developed based on assessment of local materials in the early years of the SMIL project. And you're right, there's probably not a good or effective way to ensure consistent analyses of the products that are made at the village level. But that's why we go with the standard that this is actually akin more to diet diversification, which will have the same variation of micronutrient content in those products. So the goal there is to point out that we're targeting nutrient levels based on formulation and based on general analyses, knowing that we can't go back and analyze every batch of product in every spoke. That being said, we're not on the package claiming, in this case, specific levels, but rather that these products are have these nutrients in them. To your point, though, that is something that is a challenge even in traditional fortification in countries that have legal frameworks that require it. There is a fragment of the folks that are legally required to do it actually doing it, and there right now is very little government, what I would say, oversight of that, or even analysis to confirm. So we see this in Kenya, for example, where flowers are supposed to be fortified with traditional fortification strategies. But I think if we keep it in the context of understanding this is related to diet diversification as much as it is really to fortifying micronutrients, that's one strategy. Monitoring of this through sampling and analysis is probably something that could be done just to look to see what the variability is that's out there. And that could be a very useful set of data to gather to kind of help address what this variation might be.
Just
I
to
don't know
add,
if that answers it, but Bruce.
yeah, it does. Thank you, Mario. It's what we talk about, what you've written about. But I guess just to add to that, Tim, it's a really good question. We've got the same question at the Nutrition Center and at USAID Washington and Sean Baker. And pretty much we've talked about the same thing, what Mario just said. But in PIL, it's urban. Well, it's rural also, but I mean, it's in the study we're doing in Dakar, and we're just finishing right now. We've taken the approach of adding premix and making a hybrid product with food-to-food fortification and synthetic premix, which, you know, down the road at least would guarantee that there are certain minimal levels, you know, of the micronutrients, the three that we're targeting, you know, shortfall micronutrients, iron, zinc, and vitamin A. These products in Niger also are protein fortified, which we're not dealing with in the other project, but which I think is an important factor here too. It's a good question, very good question.
I think, you know, my take on it is that there's probably lots of benefits in terms of getting children in your target populations to consume the products. They taste better, they're going to take more of it in. And so the volume may have a benefit from it. But if it's displacing, and that's important for caloric protein intake in a gross sense. But if it's displacing some micronutrients that aren't there from a corn soy blended product, there's a clear trade-off. And so that's just the thing that kind of goes through my mind. And you've been hit with this question again. So perhaps labeling not as a fortified product, but labeling it as Mario described it is a better way to, it's just greater truth in advertising.
Yeah, it's a good point. And I think what you just described is something we would like to get at by having these diet diversity questionnaires and frequency of consumption questionnaires, right? So if we look at villages that have health centers where these CSB plus products are available, we'll understand if there's a swap of those products with ours and what that would do to the micronutrient availability. I mean, the goal is that these products are designed with very similar nutritional profiles to CSB plus. But we know that there's going to be variability, to your point. So, and I think what Bruce mentioned is why we took a different tact in Dakar in an urban location where fortification has a stronger term. I just want to point out, I'm putting in the chat right now a link to a review that we did with Juanita Kruger and John Taylor on food-to-food fortification. And some of these points are addressed, Tim, in that review, exactly as you described them as challenges and what this means. Let's see if it makes it. It should be open access so people can download it, but it gives you some perspective of how this should work in synergy with traditional fortification like CSB. So
okay. That's great. Thank you, Mario. And I think that these are important challenges, and this is where the program and the project can be at that frontier for addressing them and setting, you know, providing some global public good insight into this issue. So great, and I hope you take them on not and just not leave them as challenges. Dr. Matlin, I see your hand up.
Thanks, Tim. I must say that I was really delighted, very pleased with the level of progress that Bruce, Mario, Mustafa, and the women were able to report. Clearly, you are getting to scale in terms of the volume of your products that are being marketed, and some of the profit data look very encouraging. It would be very useful in your final report or in your next report, annual report, to include trend data, because I would like to see to what extent and at what pace the scale of marketing is increasing. I was very pleased to see the branding work that you've done, very attractive labels that you've now developed and are including on many of these products. And I'm wondering to what extent the branding may be responsible for some of the greater uptake at the market level. And I'd be interested in knowing whether or not these products are now getting into supermarkets, more modern supermarkets and beyond village markets, and what are the possibilities, the opportunities, what are the constraints in getting it into supermarkets for larger scale urban middle class consumption. I was really pleased to hear Mario report on the nutritional studies that are being planned. I'm not a nutritionist, so I don't know what are the limitations of the diet composition consumption survey data that you're collecting compared to more rigorous clinical data. So I would really appreciate it if you could respond to that, and if Barbara might ask some follow-up questions. Finally, I was really pleased to see the work on the hub and spoke system and related impacts in Kenya and in Tanzania being funded by the Rockefeller Foundation. I'd like to know, to what extent is their work, their approach, has it been informed by, inspired by the work that you've done in Niger and Senegal? To what extent did you in fact provide them input, direct input and advice in that? And I noticed that both your project and their project will be coming to an end very shortly. And I'm wondering whether or not it might be worthwhile considering a workshop that brings together the East African work funded by Rockefeller and the SMIL work in West Africa to discuss what's been learned. And what are the ways forward? How can we build on that approach? And if one could bring in entrepreneurs and food scientists from non-participating countries, both in East and West Africa, to get their take and to expand the spillover of the lessons that are being generated, I think that would be a great idea. So let me stop there. Thanks a lot, Tim.
Thanks, Peter, for all your comments. Maybe just to start with the last one first, sort of quickly, that Rockefeller Foundation project was really informed and came out of the Niger hub and spoke model. In fact, Rockefeller Foundation, the Betty Kabara in their Nairobi office had heard about the hub and spoke, so asked us to write a proposal in their yield-wise, if you're familiar with that, which is now just ended, I think, a big project, and so we did that, and we were awarded. It was a $512,000 project, and it really just came out of this. I mean, it's directly tied to it, and it was successful, as I said, in both cases, in Kenya and Tanzania. So we're really pleased about that. I think your idea of a workshop is great, and we're going to do a final report to Rockefeller in May, I believe it is, and I'll mention that perhaps they could provide some funding, as well as maybe get a little bit of funding from our project. Just quickly, supermarkets from those rural spokes, the only product I know that is being bought and sold into the urban market is one called Babita out of Terra. It's a very unique kind of pasta product made from millet. It's like an old traditional product, and it's been seen by a trader that there's potential to sell that into an urban market. I don't know, Mustafa, later on, we'll talk about that. If there's more, we'll put it into the annual report. And the trend data, thank you for mentioning that. We have that data, and we will do that. And hopefully in the report, this annual report, or the If not the semi-annual report, then the annual report at the end of this fiscal year. Mario, was there anything? I think that was.
I think Peter asked a really good question that we should provide better context in on why these shifts, and Barbara, you may have some questions as well. So, Bruce and I are not experts in generating surveys for diet assessment. We have been working with experts. Reagan Bailey at Purdue, which is now at Texas A&M, has been instrumental in helping us design the tool that we're using in the Dakar study as part of FPIL. But what brought us to this is really two factors. One, of course, the challenges of doing the more rigorous clinical trial, and then with the challenges that we have in the location in COVID and the requirements of having to have Purdue staff there for the entirety of those studies. And two, getting to some of the points that Tim was making, which we started thinking more deeply about what do we really want coming out of a study like this in terms of informing direction. If we take a population of school-age children, young children, and we feed them products that are more nutritious, we would likely see perhaps some outcomes, right? And we would actually are more interested in tying it to what the markets have been doing to push those products out. So what we'll learn, Peter, and on the diet assessment side is we'll get an indication through food frequency questionnaires that are kind of designed for these target populations, what people are eating. Using food composition databases from West Africa, we'll be able to calculate what their nutrient intakes are based on that, which is valuable insight in some of these rural communities. And we'll be able to compare if diets are better with the incubation centers present and delivering of those products versus with them not. And we'll be able, through additional questionnaires related to cereal or millet specific consumption, understand if the products that are being sold with active saling, but more importantly, what's being consumed. In other words, how much can we get in terms of play here? If we can grab 5% or 10% of a market, do we see a bigger change in nutrient availability and nutrient intake? And to Tim's point, is this coming at a loss of something else? And when you're capturing those types of data, we can monitor it. Yeah, they're taking our products, but they're not consuming these other, more traditionally fortified products. Is that a good or bad thing based on the estimates we do? And then what happens if we increase consumption of our products to twice a day? We can model it then and be able to make better recommendations. So you're able to do a little bit more with these types of data relative to perhaps setting recommendations, but it doesn't fully replace the benefit of a hardcore rigorous clinical trial in that regard of looking at changes in specific status. It's rather looking at availability of nutrients in that village. And again, a lot of times what we also looked at in doing a clinical trial is you have to control things so much to be able to see an outcome you want, or you have to have such a large N that at the end of the day, we're not going to be able to financially support a study of that size within this project. It's a whole project to itself. So at the end of the day, what we were looking at is what we were going to do. This may be not just a compromise, but a good directional change based on the situation on the ground we're working in, but also the type of information that I think will be very informative to the growth and more impact of the incubation centers moving forward. It gives folks like Mustafa a real idea of where and how much product needs to be produced to affect change.
Great answer, Mario, and again, puts out a lot of future issues and questions. Shek, I see your hand up.
Yeah, I just want to add from what Bruce, Mario, and Mustafa, said, which is very important. Actually, even in Senegal, That's why, sorry about, because, I was invited to entrepreneurs, but, in Dakar, some things are like quite busy at some point. So, but my point is, your team, you raised a very good point, which is the quality of quality control and marketing stuff. And I think, in this project, SMIL, we're kind of going tour on this, and even by leveraging the nutritional quality of the products, we are working on that. And what we did here in ITA, we're working on two kind of entrepreneurs. Sometimes you see some entrepreneurs, they came with their own formulas and, gotten from some scientific, for example, our famous DG is a nutritionist guy, and he helped, many entrepreneurs, get some formulas. And what happened now, these entrepreneurs now would like to upgrade, the products. And this is something that we were working at, with them. And by doing that, we get on the point that, the nutritional table and stuff should be, get with them by doing some analysis in ITA and in others laboratory that we have here in Senegal. And this is kind of thing that is going on, and even on the sensory level also, we would like to now doing some product development using really a science behind and sensory to see really if the consumer is what is looking from this product. And I think the government also is understanding this approach, and actually even with the agro cluster, which is agropole in French, in this agro cluster, actually, the government is trying to put in each region in Senegal agro cluster in order to really control the first, the post-harvest losses, because we know that there's a lot of things going on the post-harvest losses, and also to control the quality. And that's why ITA will have in each region, in each agro cluster, which is gathering many, like it could gather like 3 regions, in one area, to make a link between the production and the processing, and also to make sure that, the quality is there. And ITA will play important role on this agro cluster. To tell you that this is something really that need to be, that we are working on, which is the quality control. And also, someone said the branding also is very important. And also, we're working on all, because we know that this is something that we really need to move forward for our product to be more competitive. Thank you very much.
Thank you very much, Shek. To keep things moving forward, I'm going to give the last question to Barbara. And then please note, team, that there are some comments in the chat box from Bettina and others about that to take a look at. So Barbara, please.
Thank you. I think your move to looking at dietary diversity is a really solid change, and I think that will be beneficial. How are you thinking about selection of households in your 600 sample sizes? I'm mostly thinking in terms of age distribution. Are you targeting households with children under 2? Are you targeting, what plan do you have there?
Yeah.
So,
Barbara, well,
yeah, go ahead, Bruce.
Well, just to say real fast, in the study we were doing in Dakar, completing the criteria was that they had to have children within the 2 to 5 year range. And that was the thinking for this too. You might have a suggestion on that.
Yeah, without knowing more about it, I probably shouldn't suggest, but fortified cereals might likely have the most impact under the age of 2, between 6 months and 2 years. And I would mention that World Health Organization has just released a revised indicator set of indicators for children in that age range. And so if you work in that age range, you certainly want to use that. And also, have you checked if the country has a demographic and health survey? Most developing countries have those on, maybe a 5-year cycle. And you can just get some interesting, both national and regional data if there is one of those surveys available.
Thanks.
And I'll
Thanks, Barbara.
add
Yeah.
other questions later, but.
Okay, thank you. We will look for that. Thank you
Yeah,
very much.
thank you.
Mhm.
Great. Let's pull this session to an end. Thank everybody for their contributions to this and lots of interesting and exciting discussion for the future. I'm going to now turn the microphone over to Mitch Tynstra and his team to present on the sorghum trait pipeline project. So Mitch, please go ahead and mute your microphones while we're getting this presentation up and running, please.
Wow, that's a tough act to follow. You guys are doing some awesome work. Congratulations.
Okay.
So first off, I guess my first question is, can you see my opening slide? 2022 annual review meeting?
Yes.
Thank you very much. Again, thank you to the SMIL management entity for organizing this workshop. It's been a pleasure putting together a summary of the work that we've done over the past year. I just wanted to, I'm not going to be talking very much during this presentation. It's going to be our research leads in Niger and in Senegal. But just by way of introduction, I wanted to say a few things about the origins of this project. In the first phase of funding, this project was titled Sorghum Trait Development Pipeline for Improved Food and Feed Value. It was a project developed with input from our collaborators in Niger and Senegal. What type of research emphasis should we be working in terms of our research activities? It was clearly a infrastructure support and development project. We had 3 PhDs involved in our research activities. We had Elizabeth Diatta from Senegal, Ousmane from Niger, and I don't know if you remember from prior meetings, Stephanie Griebel from Germany. They all were working on PhD projects. We, in the end, decided to focus on 3, we were actually focused on, can we develop traits for sorghum that are not widely available in any sort of context for sorghum crop improvement? And we decided to focus on work in protein digestibility as a continuing long-term problem. We decided to focus on trying to improve sorghum starches for end-use value. And we were working on improving forage quality using both traditional technologies, the BMR traits that are important commercially around the world, as well as new BMR traits. And so these students worked on these various projects, defining genes and genetic resources that could be used for each of these activities. And they all made tremendous progress. In fact, they all earned their PhDs. And today we're going to hear from 2 of them, I guess, again, just by way of continuity. Stephanie just wrapped up a postdoc in Germany and is now working for an NGO on human nutrition and ag development around the world. And our 2 scientists that we're going to hear from today, Elizabeth Diatta Holgate is going to start the presentation talking about protein digestibility and the really phenomenal progress that she's made in the last 12 months on that project. And then we're going to shift over to Niger with Ousmane Diakaiti, working on developing essentially from scratch a forage sorghum breeding program and some really beautiful development and progress that he's made in the last 12 months. So the team is Cliff Weil and myself at Purdue. Cliff in the last year retired. He had an opportunity to transfer to the National Science Foundation in Washington, DC, and he did that about 12 months ago. Ousmane in Iran, and Elizabeth and Cyril Diata at Isra Seras. And so the first project, there's two projects that we're going to listen to or hear about today, about 25, 30 minutes for each of them. The first is on developing sorghum varieties with improved post-cooking protein digestibility and nutritional value. We'll hear about that from Dr. Diata, and we'll listen to really a beautiful story of an emerging forage breeding program in Niger from Dr. Diakaiti. Elizabeth, you're up.
Yes.
Just let me know when you want me to advance slides and I'll advance it from here.
Okay, thank you. So I'll keep my video off, please. All right, thank you, Dr. Insra, for the introduction. I will go ahead and present the first part of the project, which is work that is being done in Senegal and also at Purdue. So just to bring a little bit of background, sorghum in general has a great potential when it comes to food. We all talk about it and know it. However, when it comes to its utilization as human food, it is constrained by its low protein digestibility after it's wet cooked. And this can lead to contribute to malnutrition, especially in sub-Saharan Africa, where it is consumed as a staple food. There is, in general, limited natural variability that is reported so far, even based on literature. We, in that same context, we recently submitted a paper in Journal of Cereal Science, in which, maybe I can, in the next slide, explain in details what we did in that study in terms of assessing natural variability of protein digestibility and other nutritional grain quality traits. So for variability, there has been a mutant that was developed at Purdue about 4 decades ago, and this mutant increase in digestibility was shown to be linked to the HR locus, which is the high lysine locus. So this locus was introgressed into 4 elite sorghum lines. This is still like just to bring like a context here for better understanding of the presentation. So part of the presentation today will focus on the results of this introgression lines that are a BC3 stage. We also developed additional EMS mutants that have shown improved protein digestibility compared to the local parents that they were derived from, BTX623. And they also have seed quality traits like seed hardness and protein content that is also improved. So far, we are exploring the new allelic variants that exist in these EMS mutants. That's also the other section of this presentation. Next, please. Oh, next. I think you went back. All right. All right. So this is just the paper that I mentioned earlier. This is just a graphical abstract summarizing the work that we did in this paper that we submitted in Journal of Cereal Science, in which we characterized a subset of the West African Sorghum Association panel, because we realized that in West Africa in general, there is a great diversity for sorghum land races and also improved cultivars. However, when it comes to the genetic analysis of this diversity for protein digestibility, it remained unexplored. So that led to our interest in doing this work. So we used just a subset of the collection, which is made of accessions from Mali, Niger, Senegal, and Togo, and we assessed them for protein content, starch content, protein digestibility, tannin, grain color, and in total there were 7 traits that were assessed. I would like to mention that this is the same panel that Dr. Maurice, Jack, and Fana genotyped at Kansas. So in general, we observed protein content in these accessions ranging from 7 to 18% in general, which is high protein when we look at the standards in terms of protein content. However, when we looked at the digestibility, we saw that digestibility only was, there was a great variability, let me just say that. It was from 1 to 53%. However, in that collection, only 2 samples, accessions from Niger, had actually digestibility attributes that were as nearly comparable to the Czech, which was the P71Q mutant in this case. We also identified in total 28 SNPs that were associated with the 7 trees that we studied here. So this paper has been submitted. Once it is published, we will make it available to the community. Next, please. All right, so in general, for this specific work, we have 4 sub-activities, and I will go through them one at a time in this presentation. You can go to the next. So the first point was to develop and advance breeding populations using the HR locus from P721Q. This work started, next please, this work started from phase 1, where we crossed 4 elite lines, which are Daru, Gent, Nganda, and Fauru to P721Q, and we performed in vitro protein digestibility test in the lab at SERA. So just to mention that this lab was established during phase 1 of the SMIL, and we thank the support for that. And depending on the cross, we identified between 3 and 14 high digestible entries. HT stands for high digestible after wet cooking. And we see an increase in protein digestibility ranging from 20 to 40%, depending on the cross. So once we identified these lines, what we did was we tested them in multi-location yield trial. So for the first 3 crosses, next please. The first 3 crosses yielded the 23 high digestible entries along with their parents as checks. In this case, the 3 local checks, P721Q, and we added also Sureno as the grain mold resistant check. And we tested them in Bombay and the Sinchumalin as for preliminary yield trial. These are the BC3F5 entries. Next. So far, the result that we exploited show that the yield in general in Sinchumalem was higher on average compared to Bombay. When we look at the lines also individually, next slide, please. It shows that it's confirmed that actually in Bombay and in Sinchumalem, we had greater yield even when we look at the lines individually. So these lines also were, for their protein digestibility values. Next. Yes, so we looked at the top ones. There was G by E that existed when we analyzed the data. So we looked at, okay, which ones are the most stable between the 2 locations, across the locations. And those are the 12 ones that are presented here in black. Among them, there were the 3 local varieties from which these lines are derived from. And their digestibility go up to 79%, which is compared to the local checks that can go up to 40% increase in digestibility. The grain mold scored, we looked at it. In general, there are 2, 3, and 4 score. 4 in terms of grain mold is quite high, but when we looked at the grain mold resistant parent compared to that, actually these lines did well. So we are planning to do a 2nd year of field testing to better assess the grain mold resistance and also the yield potential as well. In the next study, this is a 2nd year field testing. For this, we did a first yield trial in 5 locations last year in Senegal for the last cross, which is the most advanced one, which is between Fauru and P721Q. The 2 high digestible entries were tested in 5 locations in which are represented in the map on the right side, the map of Senegal. On the dot reds represent the research stations, and the green ones represent the farmer's field. Unfortunately, the way the rain season went by last year, we could not explore the data that we had from the farmer's field. So this will be the work from the research stations. Next, please. On average, when we look at the 2020 and 2021 yield data side by side for each location, we see that in general, the yield from 2020 was better for the locations. This can be explained by there was a large, how can I say, pause in the the rainfall between the first and the second rainfall that we had last year, there was a large gap. So that really affected the yield that we were able to get from last year. But in general, we look at the potential of the entries, we will see that it's actually higher than what we see shown here, seen from 2021. Next slide, please. So this is for the individual entries that were tested in 2021 and 2020. And also we have the combined yield data in red, the 2020 yield data in green, and in blue, we have the 2021 yield data. Just like I mentioned earlier, 2020 is obviously the year where the lines performed better. But however, we did not see any G by E in 2021. But there was year by location interaction. Next slide, please. All right, so this is the yield data for each of the entries that this is from only 2021. Alongside, we have the protein digestibility of each entries. So yes, the yield data of the entries were lower in 2021, but when we compare it to our check here, which is FAURU, the lines that we are trying to improve for protein digestibility, they're actually comparable when we did the statistical analysis. So these lines in terms of yield are comparable, and are also in 2021, they were stable across all locations. And we observe also a yield in protein digestibility increase going from 20 to 31%. Depending on the line. And in this case, we wanted to see, okay, what is, I would like to mention here too, that the grain mole score was a maximum of 3, and there was no significant difference between them. So one other study that we wanted to do here is to check, okay, what is the farmer's perspective in terms of these lines? So we did a participatory varietal selection. And 3 locations, 3 out of the 5 locations where we had the entries in the field. This was in Rof, Seifa, and Sinchumalem. This was done in 2021, and we had 45 farmers that participated in this PVS, where we had 19 males and 26 females. I would like to precise that this work was led by my colleagues, Cyril Giata in Senegal. So after doing the PVS, our interest was to be able to select the best lines that combine yield, protein digestibility, but also are selected by the farmers because they are the one that are going to use these varieties once they are released. So next, we did a ranking of the entries in each of the 3 locations, and this is the general view of the results. Next slide, I will show the summary of the yield potential for each line, and also alongside the protein digestibility, and also the ranking based on the farmers' preferences. So far, the best lines will be the ones that are highlighted in you next, yes, here in red. And we see that these lines have yield comparable to FAURU, and also the digestibility, but the digestibility is higher, even when we compare it to the high digestible check, which is P71Q. Some of these actually had higher digestibility, and they have a grain mole score that is a maximum of 3. And yet farmers have selected them. So this is so far the result that we have for this first activity. All right, the second sub-activity was to integrate the highly digestible protein traits, that is from the EMS mutants, into these elite lines. So as a first step, next slide, please, I mentioned at the beginning that low variability exists for protein digestibility. So EMS mutagenesis has been used to create variability. So far there is, in addition to the P721Q, here on this graph, I show the protein digestibility of the uncooked samples in blue and the cooked samples in gray. So the mutants are the ones that are highlighted in red. P721Q was derived from P721N, which is on the left side. The 3 additional EMS were developed from BTX623. So side-by-side comparison, we see in each case a decrease in digestibility following wet cooking. But in the case of the mutants in general, they have higher digestibility after being wet cooked when you compare them to the local checks, to the wild type checks. In this case, the 3 mutants also, in addition to having higher digestibility, we look at the seed hardness, which is a great component when it comes to grain mold and other processing as well. We see that EMS 1613 in yellow here has harder seeds than even the other mutants 3324. So based on this result and the protein body phenotype that we did, I did not present that here. We hypothesize that there is most likely a different mutation that is occurring in 1613 compared to the other 2 mutants that are fairly similar in terms of protein digestibility, and also they have the similar protein body phenotypes. So we went ahead and selected 1613 and 3024 to understand better what are the allelic variants. To do that, we used bulk segregation analysis where we crossed each mutant to a low digestible mutant and developed an F2-3 mapping population that was phenotyped for protein digestibility. And in this case, we use each side of the tail, which are the lowest, the left end of the tail called the lowest bulk, and the furthest right is the highest bulk. We extracted DNA, did whole genome sequencing, and did the SNP calling for this population. After comparing the SNP frequencies, we were able to identify candidate genes based on the simple mapping pipeline that we used here. And one of our objectives were to develop PCR-based primers that can be used in the lab for easy screening of the populations that are being developed. And following that, we identified recombinants that we studied and did Sanger sequencing followed by sequence alignment. Next. So the results of the BSA show that these graphs here on the y-axis is the difference in terms of SNP frequencies between the high and the lowest bulk. On the x-axis, we have the individual chromosomes 1 to 10 of sorghum, and each dot represents a SNP. So for 3224, we identify 1 candidate gene, and for 1613, we identified 3 candidate genes. Next, please. So just like I mentioned earlier, we want to clear genetic markers. So in the next slide, we show the candidate genes, and we developed also caps and tetraprimers. And these are normally primers that can be easily used in a lab on agarose gel. So we did this to do a linkage analysis to confirm first which of the mutation is the causative one. Next. After doing, so we had 3 candidate. So we had 3 candidate genes for EMS 1613. The first one is a protein disulfide isomerase. We developed the cast, in this case, they are tetraprimers that were just visualized on an agarose gel. And we clearly see here that if we see 1613 here on the left and 932 is right next to it in terms of allele, we see that the high digestible bulk is all homozygous for the EMS allele, the mutant allele. This is what we expect in the case of the high digestible entries. We did the same for the low digestible bulk, and we see some that are homozygous for the wild type and or heterozygote. In this case, we didn't find any recombinants. So far, we see that this specific mutation co-segregates perfectly with the phenotype that we observe. Next slide. We did the same study for the second candidate gene. And in this case, we identified 7 recombinants because we see here on the top bulk, which is the high digestible bulk, there were at least 3 entries that were heterozygote. And normally if they are heterozygote, they are not supposed to be highly digestible. In the lowest bulk also, we identified 4 recombinants as well that are either homozygote for the mutant allele. So that would have made them highly digestible instead of lowly digestible if this was the causative mutation. So these recombinants were studied. We planted them in the greenhouse and worked with, next slide, please. We planted them in the greenhouse and we worked with 70 recombinants that were genotyped along with the 2 parents, and we did send them for single sequencing, followed with some sequence alignment, which is the result I will show in the next slide. So for the first candidate gene, we have this sequence alignment shows that the low digestible, the C first, I would precise here, is the wild type allele, while the T is the mutant allele. So LD means low digestible and HD means high digestible. For each sample that was low digestible, we saw that it carries the C wild type allele. While when we look at the high digestible samples, they all carried the T allele. So just another confirmation of the fact that the isomerase so far is the strongest candidate gene. We did the same study for the next 2 candidate genes. And in the second one, we see that there is no perfect segregation, co-segregation, just because here, when we look at the first entry, it has a phenotype LD, which is low digestible. But when we look at the genotype, we see that it carries the mutant allele, which is the A. And the same is observed throughout. And just based on this, we will just rule out straight this candidate gene. For the third one, same thing, it does not perfectly co-segregate. LD in red, but then in the sequence it's black, which means that it's an A that is there. So it's not actually the candidate gene the gene that will be causing this change in phenotype. So far we have isomerase, but also we have primers that have been developed. So this, you can use this in a regular agarose gel. It doesn't require any equipment, fancy equipment to do this specific one. So this, we achieve our goal in terms of developing markers that can be used in early selection through marker assisted selection. Next, please. So for the other mutant, which was 3224, I would like to precise here that when we first hypothesized, the hypothesis was that it would be similar to what is in P721Q, and we're able to confirm that here. In addition, we have primer pairs also that work for this specific mutation. All right, this is the end for that study, but another work that was initiated at Purdue was the integration of these alleles, EMS alleles, into the elite sorghum lines in Senegal. And we received these populations from Purdue. And at this point, we are advancing them. We are at BC2F2 or BC3 and BC3F1, depending for these specific cross, and we are planning to continue them. For capacity training and capacity building, we were able to, during this second phase so far, train 2 master's students, and they defended their thesis in January and in August of 2021. Right, next. So far, the achievements that we have as a summary, we have many lines that have the improved nutrient content in terms of digestibility, but our goal is to propose for registration or release 3 to 5 lines, which combine the farmer preferences that are depending on the gender, are either seed size, seed color, the cycle. We have a list of these traits that the farmers enumerated. And they also have an average yield potential of about 2 tons per hectare, which is comparable to the local variety Fauru. It's also an improved variety. And we also have on average 66% post-cooking protein digestibility, which, looking at the increase, is between 20 and 31% compared to Fauru. We also were so far able to discover new allelic mutations in the disulfide isomerase protein and also on the caffeine, which are leading the improving protein digestibility in sorghum. We were able to develop also 2 polymorphic pairs of markers that would help in early selections during marker assisted selections in breeding programs. As I mentioned in the beginning, we submitted 1 article in Journal of Cereal Science. We have 1 that we are wrapping up the study, and we will hopefully submit in Nature if things work out that way. We are planning to finish that work shortly. And we have presented one poster here in the SMIL and also have one next week in Texas at SIGNA. So in terms of perspectives, what we plan to do in the next, which is I believe the final year of this phase of the project, we have different technologies that are different phases. For phase one, we have the population that we received from Purdue that we are advancing and will be used for additional marker validation. And at phase two, we have the 9 sorghum lines that are from the 3 additional crosses that will be tested in 5 locations, and the best ones will be scaled up to phase 3. And at phase 3 right now, we have the 3 to 5 sorghum lines that we want to propose for release, and we will multiply. Actually, we planted these last week in the field, and we will initiate the process of release of these entries and also validate these markers at SERAS. Next. We also plan to share the seeds with the farmers, our partners which are the farmers with Rezo, and also we had initiated conversations with industries like Sedima, NMI, and Mamel Jabot in 2020. And this year, once we multiply enough seeds, we will send them some to do some tests also in their facilities. And we are planning to do some testing of the product in terms of porridge, bread, and couscous making, and also with Sedima. And also there is this, I believe Siri can clarify this a little bit later if the need comes. There is this professor at ENSA, which is the agronomy school next to SERAS, that we are thinking about working with in terms of the full poultry feeding trials that has been done with him before with other varieties. So with these also we can partner with him. And at the end, we would like to also scale up the other technology that are phase 3 and phase 4. So yeah, this is what I had this morning. Thank you.
Thank you, Elizabeth. Sorry, I'm not able to see the chat very well. I'm just looking at it for the first time.
Mitch, there is one question of clarification that we could pose to Elizabeth quickly.
Sure, that's what I was actually thinking. If there was an easy, this is a good break to sort of ask questions about protein digestibility versus forage. Which is I'm just now looking at the.
Balua Nebiye asked a question. Are you, what are the key traits that farmers are selecting on? And are there culinary tests for the lines selected by farmers to compare against local variety? And I do see that maybe Cyril will pick up on some of that, but maybe you've got a couple of quick points.
Elizabeth, are you available?
Yes. Just like Cyril mentioned, he was the one that led this work in Senegal for the PVS, and he will give more information about that. But just like I just gave few examples in the how can I say, in parentheses, in terms of the traits that the farmers brought forward. So it depends on the appearance of the seeds. And we also observe one thing, depending on the gender, the interest in terms of the traits that were put forward were different. The female farmers will tell, for instance, based on what I got, unless Cyril, you want to take this question to better give the answer for this. All right, go ahead. Yes, sure.
Yes, I'm the one carrying the PVS study. As I will go forward during the SAWAGEN presentation, I give more detail there, but roughly for the farmers prefer the traits by sex. Mainly men farmers prefer agronomic traits such as yield, panicle size, grain size, and so on. And women farmers are more interested with quality trait. Here by quality, this is not chemical characteristic of grain, but the suitability for local food. mainly aptitude for couscous and fondue in French bouillie. It is mainly, but I will come later in detail during the SAWAGEN presentation.
Great, thank you.
I just wanted to make one quick comment about Bruce's comment here. It says, "Hi, Elizabeth, this is great work. It makes good sense that this is a disulfide isomerase." So we were doing the recombinational work, trying to sort which of these candidates is best in terms of which gene would make the most sense last fall, and it became apparent that it was the disulfide isomerase. And the follow-up work, the challenge that I gave to Elizabeth was, this is exciting. It's a brand new mechanism to modify protein digestibility in sorghum, at least that we're aware of. This mutation doesn't cause a softening of the endosperm. So it has some very interesting potential implications in translating this out into farmer adapted varieties. And the challenge that I gave to Elizabeth was we need more alleles in order to really prove that this is the gene. And so we went back to our mutant population and one of our other collaborators, actually from Ghana, and asked about, do we have any other families that might still be segregating? And he identified several families, and we're currently sorting through what we think are 4 different alleles of this mutation. And we're hoping that we'll be able to prove definitively with new alleles that other alleles that knock out the function of this gene have the same sort of modification of protein digestibility. And those families are all in the greenhouse right now. They've all got bags on them. I'm hoping that we'll have seeds to use in those protein digestibility assays probably in mid-May. And if this works out, this will be multiple alleles of the same gene that have the same phenotypes with a new mechanism for solving this big challenge for protein digestibility in sorghum.
Great, thank you very much. We'll move on, but I'd just like to toss out one idea. Doesn't require an answer now. Shek, I noticed that you put a message in the chat box, but this is an ideal opportunity. We're looking at Elizabeth's last slides for the sensory laboratory to undertake these types of analyses. And what a greater way to kick off the functioning of that lab than working on some of our in-house projects where we've got some key in-house new varieties that have some very exciting new opportunities for processors and consumers. So I toss it out and let you follow up on it. Bruce, back to you. Let's keep moving forward.
One other comment about the applications in poultry feeding is that these 3 to 5 lines that are the closest to being registered probably in 2022 also have modified lysine content and availability. And so we would expect to see differences in feeding value in a poultry context and a monogastric poultry context that might actually reduce the cost of the feed manufacturing. So it's another exciting point that we really haven't talked about.
Yes.
I'm going to jump on to the next half of the presentation. And again, I love calling these, this, we talked about this on Monday, about the importance of capacity building. And I honestly, every time I see Elizabeth, I love calling her Dr. Elizabeth. And the same is true for Usman. Dr. Usman Diakaiti in Niger is doing an amazing job. I hope you'll agree. And he's going to be leading the next part of the presentation on activity 2 of our project. Usman, the floor is yours.
Yeah, thank you, Prof. Tensta and Elizabeth, great job. I would like to present now what I'm doing in Niger. So one of the main goals of our project here is to establish a forage research program at INRAN in Niger in order to develop some OPV lines with high potential and dual purpose sorghum grain and forage to meet farmer needs here. So next. Can you hear me? Yes, to achieve our goal, we have a lab that is located in INRAN in Niamey, and I'm the leader of the team. Under me, we have 1 MSc student and 3 undergraduates. And for the research facilities, we have 1 lab, where we prepare all the seeds. All the seed processing is being done in the lab for all the trials who are conducted throughout the country. We have one office and one functional nursery in Niamey. Next. So I was saying we have one nursery in Niamey. Sorry, can you come back? Yes, thank you. We are there. So I was saying that we have one nursery in Niamey. So we have another nursery in Maradi, in which we are doing all the basics work of nursery. That is advanced line, increase seeds, particularly during off-season, and make some courses for the OPVs and the forage hybrids. And the one nursery which is in Maradi, one of my colleagues, Dr. Abkader, is managing the nursery there. He's doing a great job. And from the nursery work, we were able to do one fact sheet that is available at INRAN. Another thing is, I don't know whether you see it well. I will let, we have another, can you come back, please? Yes, we have another hybrid Sudan that is performing well in the nursery, and next step for us is to bring it in the research station and see its adaptation and on the fields. Next. Thank you. So throughout my presentation, I will be showing you some pictures of the work I am doing with my colleagues here. It's on the pathology because we are breeding for new lines. So we want to make sure that the stover quality is enough for the farmer. So here on my left, you can see that I'm working here with Dr. Karimu in Inran Maradi, and on my right with Madam Dibata. They are all a member of Inran pathologist team. So they are the one recording data for the pathology, and they took some leaf samples and sent to the US, I think at PROM's lab for a deeper analysis of the different kind of disease we observe on the field. Yesterday during the presentation, I think can you, oh, is it?
I'm
So
sorry, Usman.
Don't worry, you are very fast, but don't worry, I can manage. Another study is is the entomology, and I am doing this work with Dr. Hamed Kadikadi, who is one of the SMIL, during the SMIL phase 1, he's one of the scholarship recipients. So we are looking at the susceptibility of the BMR seeds to the storage insects. The insect you are looking for is the red flower beetle. It is one most dangerous insect of cereal under storage here in Niger. So we are running this experiment currently in Iran, in Niamey. 6 of our elite OPV, BMR OPV lines are involved, as well as to control. So data collection is ongoing. Next. So a grant and stover yield program is also being conducted in 4 Inran Research Center with the OPV lines that we've developed. So because we are looking for the agronomic performance of the lines, we involve agronomists as well, animal scientists, pathologists to help collection of data. So the pathologists are looking for the data in yellow here, like lodging and foliar diseases. And myself and the agronomists, we are looking for the agronomic data, the agronomical performance data. The good news with this trial, this is the first year we are conducting this trial across the country. So the good news is, I think Dr. Balwa from ICRISAT visited us recently. He was impressed by what we are doing here, and he supports my program with 4 new tablets. So we want to digitalize data collection of the program so that we can ensure that we have good and reliable data. Next. So actually, we were able to integrate BMR6 and 12 gene in all elite material of the Nigerian catalog. We advanced them to BACOS1, F6, and F7 stages. Next. So here, one of our elite BMR OPV that has high grain yield potential, more than 2 tons per hectare, high stover yield, more than 3 tons per hectare, and almost free of foliar diseases. My colleague pathologist visited the field in Bengu during the rainy season, and this line is almost free of diseases. You can see big panicles, good biomass yield, and very, very massive leaves. Even myself, I was impressed. I did this trial at Bengu because from the experience, Dr. Capon was asking me to conduct the trial in Bengu if I want to see the major disease, foliar diseases on my line. So I conducted here. On the picture, the man you can see here is the Abukano, the responsible of the research center in Bengu, and you can see how this line is performing in the worst locality of diseases in Niger. Next. So because our goal is to develop and release lines that meet farmers' needs, farmers' involvement in this project is very important for us. So frequently, as much as possible, we meet with farmers to get their point of view. And we also use frequently, for various reasons, we use the media to reach our farmers. Next. So another aspect of my project is also the agronomy, in which we are trying to optimize the stover production on fields. Here we compare two techniques. The first one is the double cutting technique of the biomass after 8 weeks of cropping, and the second one is the normal growth. We don't cut anything until the harvest time. For this research strategy, breeders, the breeder, animal scientists, and farmers are involved as well, and it was conducted in 4 locations with a simple design. As you can see on the green is the part that we don't cut, we leave it at normal growth until the harvest time, and in the pink, we cut the biomass after 8 weeks, and we leave the growth. Next. So after 8 weeks of cropping, this is what happens. For each variety, we cut 1 plot, weight the biomass, and take samples that we dry for stover quality analysis at the LANA. Next. So after 5 weeks after the first biomass cut, you can see the regrowth of on the fields and compare the 2 plots. On my left, nothing has been cut here, while on my left we've cut, and you can see how this line has high potential of regrowth. You can see where the panicle is. Despite my height, I think that you can easily identify how it can regrow quickly. Next. So here you have the result of this double cutting technique. In green color, the result of the double cutting, that is the first cut plus the second cut, and in blue, the result of the normal growing. So you can see that in general, there is improvement of stover yield with the double cutting technique. But really, it seems that this technique is really varietal, because if you look at the P4 and the farmer local variety, you can see that the normal growth is giving the better results. So in general, it depends on the capacity of the line to regrow. And I think it seems to be something that is varietal. So maybe if we conduct the trial again next year, we can have better comprehension of this double cutting. Next. So we also fed goat in order to determine the nutritive value of our BMR lines. Together with Inran animal scientists, we ran a feeding trial during 42 days on 24 goats to collect the data. This trial was conducted at Maradi. Next. So on this table, you can see in red, this is the farmer variety HK, and all the 5 others are elite BMR OPVs. And their pedigrees is under the table. So we looked at the dry matter intake, the manure collected, and finally, can you click? And finally, the average daily weight. And here, it's clear that, can you click? It's clear that the 5 OPVs are giving better results than the farmer variety. Additionally, if you look at the consumption index, it is clear that all the BMR OPVs have more nutrients and are more efficient for goat feeding compared to the farmer variety. Next. So on this chart, you can see what happens during the feeding experiment. At the beginning, the local variety was superior and a bit constant. But once the animal was familiar to the feed with the BMR stover, the scenario changed. And the feed based on the BMR stover was clearly superior to the farmer variety. And this was confirmed by the consumption index we've discussed on the previous slides. So for the experiment, we work with animal scientists, and currently we are writing a paper that we think we will publish very soon. Next. So another aspect of my breeding program is also to develop seed parent line. Here, the backcross program is in progress. We did the first backcross 1. A number of panicles were harvested last off-season, and they are currently, the progenies are currently on the field, and we are looking for the sterility now. Next. So while we are developing the seed parent line, we also anticipate to develop pollinators for the coming seed parents. So the team from Purdue University sent to me a collection of forage pollinators to support the hybrids development effort here. And among them, the Codatums are showing good adaptation and potential, and also one of the Sudan grass we've received, as well as the BMR conversion of the MR732. Next. So clearly our lab work is getting interest year after year from people. I was saying earlier on ICRISAT, the CSAT project, the Red Sack project asked me to join their team. In addition, we are receiving students and training them on various topics. This year, 8 of them came and were trained. Most of them will come back during the coming next rainy season. So they will continue their learning while I can focus on the major goal of the project. Next. So this year, 3 fact sheets were produced. The first one is actually a flyer. It's based on the morphological characteristic of BMR sorghum to help the field technician and students to identify the BMR plants in the segregating populations. The second one is the efficient use of the grain obtained after the process of hand emasculation. This is a good also facile for students and field technicians. And the third one actually is for a response to the iReach project. So we've submitted one fact sheet and we are waiting for the selection of the fact sheet to see whether we can conduct it. Yeah, it's based on the BMR cultivation in Niger and in West Africa in general. Next. Next. So this our plan for 2022. This year is actually critical to achieve our goals. So we will run again the phenotyping trial to get data for 2 years. After that, we will get a good volume of data to meet the requirements for the new variety registration. We had a meeting with the Committee of Variety Registration here, and we are now aware about the regulation for variety registration. In addition to that, the farmer participatory variety selection will continue. We are targeting to increase the number of farmers. At least we want to reach 200 farmers. Next. So, achievement and lesson learned. We were able to identify OPVs with good adaptation and forage quality. Here, locally, farmers clearly exhibited their preferences for many of the BMR lines that we've developed in the program. And also, I think that the great potential of and opportunity of the BMR stover over this, the farmer variety was demonstrated this year. I think I am at the end of my presentation, but before I give the talk to Dr. Tanstra, I would like to thank my colleague agronomists, pathologists, animal scientists that are with me. Some are with me in this room. I really want to thank them for their commitment to this project. I appreciate their collaboration. So I would like to say thank you to everybody.
And I want to say thank you to the Niger team as well. That's an amazing presentation. I hope you can hear it over the speaker. I'm going to quickly pull up the chat here and see if I can find where we left off.
Mitch, while you're doing that, I just want to really congratulate both Usman and Elizabeth as really being showcase model young scientists that have come through the program. It's just really humbling to see the way that your leadership on these topics has evolved by incorporating broader analyses into your narrow dissertation topics. It's just really great to see you grow. Congratulations.
Thanks.
Yeah, it makes me smile whenever I see them. It's they're emerging young leaders. And when I asked them to put together the presentations, and I said that they were going to be doing the bulk of the talking, and then to see the work, the slides that they were contributing to this combined presentation, it's really quite amazing. Congratulations to both of you. So I'm looking at the slides here. I see, hi Usman, how are OPVs developed in sorghum? I think sorghum is self-pollinated.
Sorry, come again?
It's under the chat. It says, hi Usman.
Yeah, I can hear you.
How are OPVs developed in sorghum? I thought that sorghum is self-pollinated.
Yes, it's a self-pollinated.
I'm sorry, I didn't hear what you said.
How the OPVs were developed. So after the courses, you know, I used several BMR gene donors, and most of them I use them as a donor, and I use the the elite lines here in Niger as recurrent parents. So since the BMR trait is visible early, I can do in the nursery selection. So sorghum is a self-pollinated crop. It's easy for me at heading stage to self and continue from stage to stage.
And we can start raising hands as well if there's some questions from the audience.
There's a bunch more questions in the chat here. Peter, actually, Peter Matlin says, are there any improvements to Usman? Actually, I was wondering this myself. Are there any changes in stover quality with the double cut versus the normal cut sorghum? Have you tried to measure that?
Yes, we have the samples actually at the LANA, the Laboratory for Animal Nutrition. So I'm still waiting for the results. I submitted the sample. I'm waiting for the results. They have some few challenges with some of the some of the chemicals, but I think very soon I will get the results.
Peter, I would expect that the sorghums that are cut before heading would have higher quality, whether they're BMR or conventional.
I also expect that. I was worrying about the hydrocyanic acid content, but during my exchange with animal scientists, they told me that I shouldn't worry about that because we are cutting after 8 weeks of cropping, so sorghum is enough tall, and I think the level of hydrocyanic acid is no more toxic for animals at this stage.
No, I think you're within the guidelines of normal double cutting. Nat asked a question that says, why is there a delayed response to improved forage, I guess feed value, in the feeding trial? So it looked like on your graph that it was something like 20 days before the animals really started responding in terms of improved gains with the BMR versus the conventional sorghum.
I did not get it. Sorry. Can you?
On the it's this. I don't. If you look at the slides that I'm presenting, I believe it's this figure. It shows that the BMR is the same as the conventional or even slower for the first 24 days, and then we see a improved response to feed value after 25 days or so.
Yeah. I think that at the beginning, since the animal were used to eat the farmer variety, they were familiar with those feeds. And once the animals are familiar to the BMR feeds, this is where the scenario change. And you can see that it is clear that after 3 weeks, the BMR stovers were better than the farmer local variety actually.
Sheck asked the question, I think if I'm paraphrasing this correctly, is did you see a difference in animal preference? Do the animals prefer the BMRs versus the non-BMR sorghums?
So a clear difference like this is a bit difficult to get, but we also collect data on the refusal, the remaining in the meal, and we collected it. Maybe I did not present this. We need to look at this also and see the preferences. But it can be a bit tricky to get it, whether the animal is very angry or not. It can be very difficult to say this is what the animal prefers.
There are three. Usman, make sure you spend some time looking at these comments. You've got some very complimentary words from many of your colleagues. And Jito, Faith, Jeff are all saying very nice things. Elizabeth, the same to you in response to these presentations. Bettina asks a question, are there any trade-offs associated with the BMR trait? I think he means open pollinated line varieties. I guess the first question, are there any trade-offs of BMR versus non-BMR?
I'm not sure I got the question.
Is there anything bad for the farmers of growing BMR type varieties?
So up to now, I did not get any bad feedback from farmers growing BMR versus non-BMR. I think people that are worrying about the lodging of the BMR lines in normal growing conditions, this should not be something that you should worry a lot. I am in the network where we can have access to the weather conditions in Niger, and I'm actually looking at all the weather, the wind, the rain, the temperature. I did not see huge differences between BMR versus non-BMR.
Tim Lust has his hand up for a
Oh, I'm
question as
sorry,
well.
Tim. I was looking at the chat, so focused on the words, I missed your hand. Sorry about that.
Oh, that's okay. I should have gone the other direction with it, but my question's partially been answered. It was really tied to that digestibility or that slide on the forage side. Certainly, Mitch, as you know, if you do the strip trial preference trials, generally the livestock will eat the BMRs first before they eat the traditional varieties. But I guess the one exception of that I've seen is stuff that is really, really sweet. Do you know if if your native comparison check was something that was really, really sweet, and that might be why that early performance was different?
Usman, can you answer that question? Are they, do the BMRs differ in the sweetness of the stems and leaves versus the locals?
No, I think that this is something that is shown during my presentation, but I don't have the evidence. The P15, 5 and 0 was the line that I showed the chart. This is a line drawn in the background of siphon, which is a line that we know it has a sweetness. Maybe it can be a factor that throw animals, how do I say, that made that animal, that I'm not sure I have the right word, but
the locally adapted variety, Sipon, is already sweet stemmed.
Yes.
And I don't think that we know these derivatives. They are crossed and back crossed, at least some. If you looked at all the pedigrees, there's at least 10 different backgrounds that are represented in terms of just trying to select for a diversity of types, trying to find things that exhibit decent adaptation in that environment. And so there's guineas and non-guineas and there's short grain types. Actually, the ones that there was a question about the double cuts on one of them, it didn't look like they performed well in the double cut. And part of the reason for that is that's the recurrent parent in that case is a short grain type, and it didn't respond well in a double cut scenario. Any other questions in the chat, or now that I'm looking in the pictures? I'm sorry it took me so long to look at that. Bella, from our experience, animals prefer lines with sweet, juicy stems compared to the local varieties that are highly lignified. Yes, in fact, I know that in Senegal, Elizabeth is also asking questions, getting set up to do similar work. And one of the varieties, and I forget which one, Elizabeth, the farmers already know that it's sweet stemmed and the animals prefer it. So they're looking for an opportunity. I don't remember which one of those 4 that was in the list. And we were surprised when we asked them where the value was, and they said there's as much value in the forage as there is in the grain in terms of from a farmer accounting perspective.
That's great, everybody. Thank you very much for your presentations. We're going to transition to the next one, which is Jeff Morris and his team on the SAWAGEN project. And it's also, I'm just going to use this opportunity while you get set up and ready to go. Jeff, you did bring up an interesting point about there could be a potential trade-off with insect damage during the growing season, and that makes a lot of sense based upon what we know you found for the mechanism for host plant resistance against sugarcane aphid, and that's negative impact upon potential feeding quality. So Usman, again, follow up again with your with Hame during the season and do some additional evaluations and see if there's any insect resistance issues which come up. But great point, Jeff, and please, you have the microphone to get started.
Yeah, okay, great, thank you. That was really inspiring as always, Elizabeth and Usman. Wow, so thanks so much for that. Let me share my screen. So okay, so we're going to give you an update today on the progress towards delivery and the progress towards durability of the network that we're building together on improving sorghum adaptation with genomics-enabled breeding. And I want to thank all my co-PIs and also the people not listed here who you're going to hear from today, and others you're not going to hear from today who are important contributors to the project. So what we're doing in this project is building an effective and durable R&D network for West African sorghum. And what we're envisioning that would be effective is simply a program that's regularly delivering adapted varieties, better adapted varieties that are actually adopted to farmers and end users. Yep. Hello? Okay.
Please mute everybody. Take a second to mute your microphone.
And as we know in the past, it's been sometimes really hard for breeders to deliver varieties that are adoptable. Many of these breeding fundamentals have been addressed really well in recent years through a lot of different groups' efforts on, say, getting good product profiles, getting really close work with the farmers and the cooperatives. And these are themes, of course, that the advisory board has really helped us with over the last few years. But then on the other side, breeders had real technological challenges, and it's been difficult in the past for researchers who are there to support the breeders to align their programs to help the breeders. So what we're looking for really is this alignment. We're delivering new locally adapted varieties to the seed system in the next couple of years starting. And this local adaptation focus is very much influenced by the Tynestra project, seeing the successes of being very, very focused, trying to just deal with one problem at a time, delivering, and then moving to the next one. And we're also thinking about how do we get to a point where there can be genetic gain year over year? I mentioned yesterday about elite germplasm pools not really existing in the region. And one of the things we've been doing is trying to develop those elite gene pools. So the local adaptation platform that's led by Dr. Jacques Fay is really focused on this near-term delivery, really similar to what the Tynestra project's been doing, but with adaptive traits. And then the broad adaptation breeding platform led by Dr. Cyril Diatta is focused on really developing this elite germplasm that will set the stage for long-term genetic gain across the region. On the research side, we have the genetic mapping research platform that's delivering knowledge and technology to facilitate the breeders. That's led by Dr. Fana Maina, and the physiological mapping research platform led by Bas Sin, who is developing, again, knowledge and data that facilitates the breeders. Today, we have time to hear from Fauna, Jacques, and Cyril on 3 of the platforms. And before we do hand it over to them for the rest of the presentation, oh yeah, sorry, one last thing. Just the thing that, you know, we ask you to look for is how the delivery is occurring within the project in these gray lines and to the farmer organizations. That's like the marker, that's the kind of key indicator of effectiveness and durability. Are these scientists delivering to each other, and are they delivering to the seed system? Before we jump into SAWAGEN, if Danielle is here. Danielle, are you here? Okay, Danielle Fonseca, not here. Okay. Danielle asked us to highlight a few points on the sustainability, the durability of the network. There's been questions in the past, really good questions from the EAB about the sustainability of the network, and Danielle Fonseca really wanted to emphasize that this network will live beyond this phase of SMIL, whatever happens, because it's not the only project building the network. SAWAGEN has its focal areas for how it's building the network, but that's a part of a whole ecosystem building these networks. So one is the EAVO, whoops, sorry. And then across other Feed the Future initiatives, they're really built to leverage each other. So this is not going to go away if USAID takes another direction on sorghum in the future. Okay, with that, I'm going to hand it over to Dr. Jacques Fay for the update on the local adaptation breeding platform.
Okay, thank you, Dr. Morris. Can you hear me?
Yep.
Okay, thank you for the introduction and setting up the floor. Good morning or good afternoon, everyone, depending on where you are. So I am Jacques Fay. I'm sorghum geneticist, crop geneticist in general, based in Sierras, and I'm leading the local adaptation breeding platform. So I'm glad to be working with my colleague breeders, Cyril Jata, for example, from Senegal, Nofu Ouedrago from Burkina Faso, Jacques Agata from Togo, and the molecular geneticist Terry from KSU and Falamaina from Niger. So in this, oh, can you go? Thanks. So in this platform, we have the main objective, which is to develop and deliver improved version of varieties that are locally preferred by growers and that have some quality trait, for example, and integrating some winning traits such as striga resistance and stay green drought tolerance into those local varieties. So we have 5 main sub-objectives, specific objectives for this platform. 3 of them consist of developing versions of these varieties that will have striga resistance. So the LGS1 is a locus or a gene that confers striga resistance. And the 3 sub-objectives are to develop a version of, for example, Capelga and Faru. Capelga is a variety that is preferred by some of the farmers in Burkina Faso, and Faru, another local varieties preferred by some of the farmers in Senegal. So those will be improved to have the stay green alleles. So starting with the product that we are developing for the Senegal, some of the farmers, trying to improve Nganda that will be having the striga resistance. So the cross has been started quite a few seasons ago during the start of the 2nd phase. And we are currently at the DC2F1. So the approach that we use in this platform is to apply marker selection to rapidly and effectively advance lines by selecting those that have the favorable alleles for a given trait, in this case, striga resistance, for example. And so we have been applying marker selection efficiently, and right now we are just planting the BC2F1 progenies, and hopefully at the end of the heart of season, which I mentioned here as S, that we will be having the BC2F2 progenies. So those will be advanced during the rainy season to get the BC2F3, and we'll start the pot evaluation during the cool off season of the 2022 season. So can you go back, please? Okay, thank you. So, we have already identified the different hotspots for striga evaluation, because we at Senegal, for example, we don't have a research station with infested area that we can test the lines that we are developing here. But those hotspots in the farmers field have been already identified, and we will proceed to a seed multiplication once we get the BC2F3 lines and start the evaluation. So by the rainy season of 2023, we will be able to evaluate those on farm and applying particularly variety selection before the registration of those lines, and deliver them to the seed system by 2026. So there are some delays here, as you can see it, but those are due to some challenges that we face at the beginning of this development. Next, please. So for the product we are developing for Togo is to improve version of Sorvato. Sorvato is a line also that is preferred by farmers over there, and we are improving it for striga resistance. So the cross has been already made. We applied marker selection to select lines that have the LGS1 allele, and currently we are at the BC2 F4 generation. So those there will be advanced to BC2 F5 at the end of the heart of season, and hopefully we are going to evaluate them during the rainy season of 2022. So marker selection has been working so far for this product, and hopefully we will start the seed multiplication during the rainy season and try to get those lines registered by the end of this phase. So as you can see here, this is the picture of the sorghum breeder Jacques Agata from Togo with some of the nursery lines of the BC2F4 at Togo. Next, please. For the improvement of Mota Maradi for Niger, so the cross also has been initiated, and right now we are at the BC4 F1 generation. So we applied marker acetate selection as for the other products, and at the end of the dry hot season, we will be at BC5 F1 or BC4 F2. So hopefully we will start the field evaluation of the progenies that will be developed at the end of the rainy season, at the end of the dry season during the field season of 2022. So as you can see at the pictures here, for example, the sorghum breeding program at Niger, they have already identified the different hotspots for the evaluation of these lines. And at the picture at the right-hand side with Dr. Aisatou Mamadou, sorghum breeder, you have some of these progeny already in the field with some good-looking traits that have, according to the marker profile, the LGS1 alleles. So we will proceed also to seed multiplication at the rainy season of 2022 and start processing for the registration and delivery seed to the seed system by 2023. Next, please. Another product also aiming to develop, to advance or to improve a version of Mota Maradi, but this activity has been taken by Dr. Thierry Ferrerhoff from KSU and Fana Maina. So this population that you can see here, they were developed at KSU for the development of this striga marker and the validation of that marker. But right now they are transferring those population to Niger that will be also tested at the Niger side. So germination assay is ongoing also at Penn State with the collaboration of Dr. Jesse Lasky. And during the rainy season of 2022, we will be evaluating those lines at the different research stations across Niger. Next, please. And regarding the development of Capelga, a version of Capelga for the Burkina Faso smallholder farmers, the market selection has been applied efficiently, and we selected lines that have the drought tolerant or stay green alleles. So those have been crossed to the recurrent parent Capelga, and we are currently at either BC2 F1 or BC1 F2, depending on the generation. And at the end of the dry season, we will be BC2 F2 and BC1 F3. So this line have already been planted in the field, and very soon we will start the genotyping and the selection process. So hopefully we will be starting the field evaluation for the BC1 F3 starting this rainy season through 2022, and hopefully proceed to seed registration by the end of this phase. So the picture here we see Nofuwe Drago, the sorghum breeder at Burkina Faso, with the same progeny from this cross. And if you see, for example, the picture of this sorghum, we can see the phenotype of B35, for those who know the phenotype of B35, which is also showing how this selection is working, just based on the marker profiles. Thank you. To the next slide, please. And lastly, another version of Faru. Faru is an elite line for Senegal, but we are aiming to improve it for drought tolerance, especially post-flowering drought tolerance with stay green. So applied same as the other products, marker selection. We did select the lines with the favorable alleles. And right now we are at the BC3 F2 generation. So these lines there have been already planted in the field. And at the end of this hot season, we are harvesting the BC3 F3 lines. So we are getting those lines. So we will be starting field evaluation, starting this rainy season on farm. And during the cold off season, we will be also undertaking some lysometer experiment to just validate whether the lines that we selected based on the marker profiles, they are predicting the stray green phenotype. So this is just a side activities to give us more confidence about the integration that we have been undertaken. Okay, next please. I think that's the last slide for me. So the expected progress that we are aiming to get at the end of this season is that we are continuously going to implement marker selection. So we have been successful so far, but we are going to implement it. So for all the breeding programs, to use marker selection to develop varieties very rapidly and very effectively. So we'll be, for most of the products, starting the field evaluation, either in hot spot or on a research station for the different products. And we are hopefully we are going to be at that if everything goes well. We will be also testing whether the lines that carry the stay green alleles have the phenotype as we expected during this coming rainy season. So we face some challenges, for especially regarding the striga improvement, because the evaluation, we don't have, for most of the programs, the facilities for testing for striga resistance. So we identify hotspots, but some of those, they are far away from the research station, and traveling is kind of a little challenges because of the frequency that we might go there. So that would be a challenge. Another difficulty is the long distance and the variation in the different hotspots that have already been identified. So hopefully with time, we will have some facilities that will help us to develop this product as quickly and test them, not having to go to find some hotspots. Thank you, and I will give the floor to Dr. Cyril Jatta to give us some updates on the broad adaptation platform.
Thank you, Jack Martin, for introduction and my greeting for everyone. I'm Cyril Jata, leading the broad adaptation breeding platform based at Seras. Next. For this platform, the objective is to develop broad adaptive germplasm as a foundation for long-term variety delivery. And for the SMIL phase 2, we have 3 activities such as, with the development of BCNAM, built environment and participatory varietal selection of minimum lines. And the third is the adoption of the breeding management system. Next. Next. Okay, for the development of the West African BCNAM population, the objective of this BCNAM is to develop broad adapted germplasm as a foundation for long-term delivery with genetic gain. And for that, we have 4 recurrent parent and 16 donors. The recurrent parent are the elite varieties for each. Recurrent parent are elite varieties.
Those genes.
Are you hearing me?
Yes, we hear you.
Okay, the recurrent parent are elite varieties for each country: Uganda for Senegal, Sepon for Niger, Sorghum for Togo, and Sariaso 11 for Burkina. And the 16 donor are selected parent based on the product on constraints and farmers' preferences. So as you can see in the table right, most of the F1 population have been developed, and for most crosses, we are in BC1, F2. Another thing I can say here, we really appreciate the discussion we are making on the development of the BC now, because we have advice of our elders, Geoff Morris, Daniel Fonseca, and Jean-François Rami from SIRA, as they have already experienced this type of development with ICRISAT. Next. Next slide. For the multi-environment and participatory selection of the minimum lines, we use it. We use also. We have 2 types of evaluation. For on-farm, on-station evaluation, we evaluate 25 promising minimum lines we identify from the phase 1. Those lines have been evaluated at Bombay, Rof, Sinchumalem, Sefa, and Sekaimor. And for on-farm evaluation, we evaluate 7 lines based on 2019 and 2020 data. Those lines have been evaluated on farm, and you can see in green position the localization of the on-farm fields. Next, and for the result of this evaluation, here we use GG by plot analysis to evaluate mean grain yield performance, but also stability of genotypes. And as you can see, for grain yield performance, E400 and E300-1 are the best performing for grain yield. And for stability, we have E269 and E270-2 as best stable for yield over environment. In blue, we have the different environment, and in green, the lines. And the average yield is ranging from 1.5 to 2 tons by acre with a grain mold score around 2. Next. And for PVS evaluation, I recall that it is the same Elizabeth was presenting. I will come in detail here. For the PVS, we run it at Rof, Sefa, and Sinchumalam, representing the different agroecological zones in Senegal. We use next. Okay, a total of 45 farmers has been involved with 26 women and 19 men. The method of vote using green, yellow, and red card had been used. For identifying farmers, red focus group has been used, as you can see in the photo. Next. And for the ranking of the best millennium lines, according to farmers, we identify 5 best millennium lines here in blue in the table on right. Next. And to answer Balwar's questions, there are the main farmers preferring traits, and globally, as you can see, men mostly prioritize agronomic traits. Here in the table in green, you can see even in Sefa, Rof, and Sinchumalem. And roughly for women, they prefer grain quality and agronomic traits. I try to put it in orange in this table. Then next. Here we are trying based on agronomic performance and the previous results. We select the best 5 lines based on farmers' preference and agronomic trait. And for the next step, it is the same for SMIL desirability best lines. The next step for both projects will be the multiplication of the best 5 lines, the 5 line from SMIL designs and 5 lines from minimum lines. We will test them for suitability for local food. It is also answer for Balwar's questions. During this year, we are currently starting the registration process because of the 5 line, the 5 minimum line and the 5 best digestible line are currently on field for seed increase, and for when we harvest, we will process for suitability for local food, and we will do it with IITA. We will discuss with them. I hope Shenja is here. Don't worry, we will work with you as we did in the last with the last breeding line we developed under the WAT project. We will follow the same work, and we hope by the end of 2023 the best minimum line and the best disease line will be on the seed system. Next. Also, our last activity is the digitalization of our program. And for the 2021 activities, all NAS. Here it is Senegal, Niger, Burkina, and Togo. We all use, all breeders and our technicians have been trained on BMS, and currently Herman is at Burkina for that. All the 20 field books also has been preparing using the BMS. And most of our historical data are being migrated also on the system. And that you can see in the map, we are now collecting our data using tablets and barcode reader and label printer have been processed into the ABI project. Here we have, in Senegal, we have our material Senegal, Burkina, and I hope Niger. They have already processed the field label printers. And we are working with the focal BMS person, Herman, for label printing. So the next step will be the implement of the barcode field labeling and training on seed system management. And I hope for labeling it is very important because currently we are using manual labels, and we will move during the coming rainy season from manual labeling to barcode field labeling. Another thing I can add is the connection I'm making between SMIL digest, SMIL SAWAGEN, and SMIL phytopathology. Currently, I'm in nursery, the best mini-NAM line. I will cross it with the best disease line. And then yesterday, in the presentation of the SMIL phytopathology lab, MAM are identifying best anthracnose and grain mode line. Then I will cross them again with this the best mini-NAM, the best anthracnose and grain mode line that will come from Mampenda experimentation on the hotspot. It is the end of my presentation. I give the floor to Fanamaina to present the genetic map research platform. Thank you.
Thank you, Cyril. So I'm Fanamaina, the platform lead for genetic mapping research platform GMRP, assisted by Jacques-Martin Faye and Bassirou Tourné from ISRA Serras in Senegal, and Dr. Thierry Federhoff from Kansas State University. So the objectives of the genetic mapping research platform is to deliver genetic knowledge and tools to breeders that solve their roadblocks and backups. Specifically, we will generate genetic knowledge that guides breeding strategy and methodologies, and also develop genetic tools to facilitate breeding. Those will be trait predictive markers and also background markers. So some of our anticipated research results are to develop Cas markers for striga resistance allele at the LGS1 gene, and also to develop genetic maps, Cas marker, and neoisogenic lines for novel drought resilience traits. So before going deep in this presentation, I would like to present the workflow from genomic discoveries to varietal release. Here we have the 5 steps. So genomic discoveries, marker development, marker testing, marker assisted selection, and also variety release. So for the genomic discoveries, we'll have quantitative genetics and working on drought tolerance and striga resistance. So here we'll make new discoveries and also take advantage of existing discoveries. And from those new discoveries, identify markers associated with drought tolerance and striga resistance. We will develop Cas markers and design Cas markers and then validate them. And also we'll be able to develop new markers. So we'll validate the markers and see whether we have to go back to new discoveries and also take advantage of the existing discoveries. The next step will be marker testing. So using the diverse germplasm and also breeding populations. And then once we have validated those cast markers, marker-assisted selection will be used. So either in early generation selection or also for the breeding population, back crosses, neo-isogen lines, and also recombinant bred lines, before going to the variety release and testing. So those also will be for phenotyping, validating the markers and the traits associated with the trait of interest, testing in farmers' field, and then the breeders will be able to develop drought-tolerant varieties and striga-resistant varieties. So the progress we made in 2021, we developed cast markers for striga and validate them, also for the drought tolerance, and we delivered them to the local adaptation breeding platform that Jack Fay is leading. We also evaluate striga resistance via germination assay. So those ones, we will evaluate them, and also we validate the lands that have favorable and unfavorable allele at the LGS1. We conducted quantitative trait locus mapping for the drought stress for the West African Sorghum Association panel in the phase 1 and also in the phase 2. So some of the results were published by Jacques, and also some were submitted. So now we are working on marker development and also testing for novel drought tolerance PTL, including the existing discoveries that we have for the stay green markers. So for the striga evaluation assay, the hypothesis that we have our hypothesis is that the favorable allele of LGS1 gene confers striga resistance by reduced germination stimulants. So we conducted striga germination assay in pots for known varieties. So either they are putative resistant or putative susceptible. So this assay was conducted in pots during the rainy season in Niger. And the genotypes that we use include the SRN39. So in the local adaptation breeding platform, we have the development of striga resistance from different breeding programs. So we have all SRN39 from different breeding programs that we are testing and validating them. And also we are conducting now validation for backcross population from Kansas State University, which is ongoing at the striga germination assay lab at Penn State with the collaboration with Laxity Lab. So for the drought stress markers, we found evidence of drought adaptation in the West African Sorghum Association panel. So our goal here is to deliver drought tolerance markers for West African breeding programs and also African breeding programs working on drought tolerance development. And we identify marker trait associations, which is a genotype to phenotype association with drought response in the West African Sorghum Association panel. We identify marker trait associations that co-localize with non-stay green genes. Next, please. And also we identify novel markers associated with drought adaptation. So the figure that you have the African map in your right is showing some allelic distribution of marker trait associations found on the chromosome 3 of the 3 of 10 chromosomes of sorghum. So the orange one and the black one, the light African map, we have a rare association allele that confers drought adaptation in the West African Sorghum Association panel. And also the darker African map, it is another common marker trait associations across Africa. Next, please. So in our experiments for the lysimeter, which is a managed environment conducted at ICRISAT Sadore, the goal here is to discover and deliver trait predictive markers underlying water use under drought stress. So we conducted the experiment in the lysimeter by measuring the transpiration of the West African Sorghum Association panel, which is a subset that we use of 219 genotypes. So over 12 weekly. So the time points, it is 12 weekly time points that we have, and we found significant genetic variation in water use. And also marker trait associations that appear at 2 to 3 consecutive time points. So the figure in your light, it's a genome-wide association study, really simplified. In the x-axis, we have the 10 chromosomes of sorghum. In the y-axis, we have the time point. So the days after planting by time point. At from 43 days after planting to 113 days after planting. So each single vertical bar you are seeing, it is a marker trait association, and the color shows the significance of the p-value. So the intensity of the p-value, sorry. So the red will be a higher intensity, and then lower blue, it is a lower intensity. So we found that we have some of the markers appears at 2 or 3 consecutive time points. So in the well water treatment that we have here, we have at the first marker on chromosome 1, we have at days after planting, 92 days after planting, and then 99 days after planting, the same marker is appearing, and we have several marker trait associations appearing at 2 or 3 consecutive time points that we measure, and later they disappear. So this could be some findings that we can use for future studies. And those markers could be used as trait predictive markers in breeding for climate resilience. Next, please. So in the West African Sorghum Association genome-wide association studies, we identify novel markers that underlie drought response, and they are being tested. So we developed 11 CASP markers that are ready for validation. We also evaluating CASP West African Sorghum Association panel drought-tolerant varieties under the managed environment at in the lysimeter at Bombay in Senegal. Those include the putative drought-tolerant accessions that we found in the WhatsApp, and also donor accessions of putative marker trait association. So donor accession will be the favorable accessions that have the favorable alleles that we are looking for. And we are working also on the progeny of B35 or BTX642, a post-flower drought tolerant by Nganda, which is at BC3F3. That so the progenies carrying the favorable allele will be evaluated in the lysimeter next year. So coming to our workflow, to summarize, from genomic discoveries to the marker development, we conducted quantitative genomics studies that are publicly available to the global scientific community. We identify markers that are new discoveries, and also we took advantage of the existing discoveries, for instance, the LGS1 and the stay-green markers. We validate the CASP markers, and they are available, freely available at Intertech, and also registered in the Excellence in Breeding. For the validation, we validated them in the field lysimeter and also lab assay in the case for Striga. So the marker testing that we have all were conducted that we are seeing here. We tested in the West African Sorghum Association panel and also the Global Gem Plus. And the local adaptation breeding platform led by Jacques Fay and broad adaptation breeding platform by Cyril Diatta are using those markers. And then for the drought, we have the markers for stay green and also for the Striga LGS1 that are being used for marker-assisted selection. And in the future, some early generations will be tested, and also backcrosses can be tested. Near isolation lists will be developed, and also recombinant breedlands that breeders can use. So those will be what we are hoping in the future. And also for the variety testing, we will have the hypothesis testing in farmers field, whether we have the true favorable allele comparing the resistance to Striga and also tolerance to drought, so that the drought tolerant varieties and Striga resistant varieties will be delivered to farmers. Thank you.
Okay, thank you, Fana, and thanks, Cyril and Jacques. And so just to finish off, hopefully we showed you a few examples of some of these arrows that that we had put in here. We're really close to delivery to seed system. We meet twice a month, and we have for the last several years on Zoom, even before COVID. And every time we meet, we talk a little bit about what we need to be doing to make sure that this delivery happens. And you see there's a few things in the pipeline, and that with those hopefully future successes underway, that will really help kind of draw in the demand for these future breeding products and future deliveries from the researchers to the breeders. I think one thing that's really great to see, that I think probably people have been seeing over the last few days, is not only the delivery within projects, but the delivery across SMIL projects, leveraging each other, leveraging outside projects. So we really do believe that we're on track to make this an effective and durable R&D network. Okay, so I think we're hopefully have time for questions.
Jeff, did you want to start off with the ones you noted in the chat box, and then we can go to people raising their hands and we can have them ask their questions?
Yeah, okay, so I'm just checking out, going back to those. Okay, so I think the first one was from Amare Sayum, and I think that's maybe a question for Jacques. So the question is about the size of the populations that you're using, Jacques, along with the breeders for the LGS1 marker-assisted selection, and about selection intensity for genetic gain in that program. Jacques, do you want to take that?
Okay, so which question is that you said?
It's a little ways up. It's Amar Sayum.
Okay, the size of the population for the LGS1.
Yep.
So for the size, I mean, it's kind of like depending on the breeding program. So, but for the genotyping, for example, we make sure that at least 4 plates, so each plate has 96 entries or genotypes that we will send for genotyping. So I hope that is going to give you a rough estimate of about 384 lines for each of those population, but it depends on the breeding program. So really, the intensity of selection. So for example, Jacques Agata from Togo, he selected all the lines that have the LGS1 allele, for example, and try to advance them to the next generation. So it depends. For Cyril, for example, he selected those that have a combination of alleles for other traits, for example, for let's say stay green and LGS1, because the genotyping we did for the same lines that we sent for genotyping, we integrated both the stay green alleles markers and the LGS1 markers. So a line will have both, for example, allele for LGS1 and stay green, and serial selected all those lines that have, for example, both alleles, or sometimes one allele for a given thread. So it depends.
I'll maybe add just a point about.
As a complement of what Jack Martin said, in Senegal, mainly for population, we are targeting around 300 to 400 lines. And for the intensity of selection, when we are running PYT, it is around 10%, and the final selection is 5% for the intensity of selection.
Okay, thank you, Cyril. I was going to just add a little context on the genetic gain question. It's a really good question. One thing to point out that those particular populations are not designed for genetic gain. They some genetic gain hopefully will happen, but they're not designed for genetic gain. In the local adaptation breeding platform, we're really trying to take a more of a defect elimination approach. And the reason we're doing that is, in the past, if you go through the whole history of the pedigrees and the breeding approaches in West Africa, it looks like one of the reasons why some of the programs underperformed compared to what they were hoping for is that they were trying to do defect elimination on traits and genetic gain at the same time, and they took on maybe too much all at once, and then they didn't get the defect elimination they were looking for, and they didn't get the genetic gain that they were looking for. So what we're trying to do is break it down into two steps. Right now, make sure that we can do the defect elimination properly with the local adaptation breeding platform, and then the genetic gain we're setting up with the broad adaptation breeding platform. But it's totally possible in the future, once we get both of those pieces working, we can do both the trait-based defect elimination and the genetic gain. We're just not quite there yet. And then I think, Jacques, the next question is probably for you two, from Elizabeth. Can you see that?
Elizabeth, let me see.
Just the next one down from Amar, about the multi-location field trials and which generation we're doing it at.
I don't know if I'm having a rightful chat. The last one is by Dr. Hausman.
Oh, we went back up to the top, the top. So Elizabeth's question.
The question from Elizabeth is easy myelin processing is. Can you repeat the question?
It's one further up. So she's asking, why are we doing multi-location field trials at like BC1 F3 or BC5 F3? Isn't F3 still segregating? Wouldn't it be more beneficial to test at more advanced generation like F5?
Oh, okay. So yeah, technically it would be best to test at further generation like F5, for example. But as you know, we are applying markers to selection. So we are able to identify lines that are fixed for the disabled alleles, for example. And at the BC3, yes, they are still segregating. But the lines that we are using for the testing, we want to make sure that those they are fixed mostly for the disabled alleles that we are targeting.
Yeah, so Elizabeth, just to follow what Jack says, totally agree. There's just the trade-off between waiting to have more pure material and not getting the information sooner. What we're trying to do is basically exclude our hypotheses as soon as possible. So if there's evidence that a breeding strategy is not working, we want to get that evidence as soon as possible. It's true, it won't be high quality yield data yet because of the remaining variation. Okay, let's see. Okay, I think the next one. Okay, we're still for you, Jacques, from Balois.
Yeah, the one for Balois.
Yeah.
Okay.
And maybe
yeah,
leaders on the call, they can address that too.
yes, the breeders can reply to this one, but I wanted to just say that what we said at the beginning of this developmental work, we said at least we're gonna limit at BC2 and F, let's say 3 or F5, depending on the breeder preferences, because we are applying markers to selection. But some breeding programs, they are advancing more quickly than others, and depending on the recurrent parents and the donor parents genome recovery. So they might go to a BC5, F4, for example, for Burkina Faso and Niger, for example. So it just depends on, we just give them the freedom to develop to stay at which generation they would like to be. But at least BC2, we are going to have those. Each breeder can reply to this. Is a decision that we made at the beginning.
Yeah, let's see, who do we have on the call? So I know Cyril is here. Is anybody else? Maybe Cyril is the only breeder on the team that's on the call. Oh no, Ardali's here. So maybe, I don't know, Ardali, do you want to say something about your choice of how many backcross generations to use?
Yeah, thank you. It depends. In Niger, we have how they call it, season and rainy season. It depends again of the experience of the breeder. Some breeders are more experimented than some breeders.
Okay, thank you, Ardali. Cyril, do you want to comment about your decisions?
Okay, usually in Senegal, we will evaluate BC3, F3. As Jack said, we are applying markers to select the best lines that recover the recurrent parents. So we will combine the markers result and also what we saw in the field based on farmers' requirement, because we already run PVS. We know the trait that farmers would like to see in our improved variety. It's by combining several strategies that we will use to select the end users' lines.
Great. Yeah, and so in general, like just as a whole, Balawa, you know, as you know, like the number of back crosses in a perfect world, you know, we're going to design the number of back crosses based on how exotic the donor is, right? So if the donor is very exotic, very maladapted to the location, we would do multiple back crosses. If the donor is actually pretty close to being an elite, maybe, you know, we would just do one back cross. What you saw there doesn't perfectly reflect that strategy, because, you know, we were kind of working out with the different programs what was tractable and feasible. But in the future, as we go more and more, it will be kind of designed based on where the donor falls between eliteness and exoticness. So let's see, I think we're almost caught up. Okay, new question from Bettina. Intent to go, so Bettina's asking if there's intent to go beyond the low germination stimulant allele for strag resistance. I think maybe Fauna, do you want to take that, since that's your primary responsibility on the genetic discovery?
Yes, so this was our original plan, to not only for focus on the LGS1 trigal resistance, but also for the mechanical barrier, for instance, and M13. And we are working on that, and Cyril data is developing populations that we will be using soon with Uganda by M13 progenies.
Okay, thanks.
Yeah, and so yeah, and that was one of that is in our project plan. Fauna just didn't mention it in the interest of time, but we definitely want to leverage all the great work on the N13 resistance. And then also Fauna and I will be working with Jesse Lasky for a new Gates funded project on allele mining, where we'll be doing further where we'll be aiming for further discoveries on novel striga resistance mechanisms. And I think we're caught up on the written questions. I'll double check. And then Mitch has his hand up.
Great presentation, everybody. I was just, in the context of this nice graphic that you have, the two big examples of traits that you're looking at in this iteration, striga and stay green, they have a lot of interactions with the rest of the way sorghum does its business, in terms of just about every other thing I can think of, in terms of what the plant looks like and how it lives and does its business in its environment. How do you start thinking about all the complex work that needs to happen in a breeding context of trying to address or balance all of these other pleiotropic effects, or the pleiotropic effects on other traits? If you have any, I'm just curious.
Yeah.
I don't have an answer.
Yeah, it's such a great question, and it's one of the reasons why I've become obsessed with this kind of reductionist approach of focusing on one allele at a time, making near isogenic lines as soon as possible. It's not because we don't acknowledge the kind of holistic complexity. It's exactly because of that kind of holistic complexity that you're talking about. Pleiotropy, which for the non-geneticist is one gene having many effects. Like everything we know about biology suggests that every kind of important trait we want to manipulate with one gene, it will affect multiple traits. But the approach that we're using on the local adaptation breeding platform, leveraging the learnings from Mitch and others, is that if you have a really complex trait, you have to make the genetics simple so that you can quickly test the hypotheses on negative effects. So now, because Fauna and Terry have made these near isogenic lines for LGS1, there's a number of things that we're concerned about that LGS1 might be messing up when we select for that knockout that Kabisa Jeta's group has discovered and characterized. And now it's going to be actually quite straightforward to test that, because we've isolated that that one gene. So if it does, for instance, mess up nitrogen uptake, right, because strigolactones are important for mycorrhizal interactions, we would have a chance to figure that out fairly easily. Fauna, do you have anything else you want to add to how we're addressing that issue?
No, thank you.
Okay.
Thank you, Fauna. Nice answer.
I think Peter was the next with the hand up. Oh, you're still muted, Peter.
Yes, yeah, thank you very much. General comments. When the SAWAGEN concept and architecture was first presented, I think we have to admit that some of us on the EAB, we were intrigued by it. We loved the starting from the local materials in your left-hand column there, and building on those and improving those, knowing that they're already well adapted both to the agroecologies as well as to what farmers want and need. We were also intrigued and very much like the combination of the high science, the marker-assisted selection and the genomics work with the PVS and introducing PVS at appropriate stages and getting useful and timely feedback. But I have to say, we were concerned that it was complicated and would it work? could you actually get these synergies to operate, to function as you expected them to? And would the information material flow in a timely and effective way to achieve your bottom line delivery targets? And I must say, you have not only demonstrated proof of concept of the overall concept and architecture, but you're delivering results and by the end of this project, made a real contribution to regional sorghum improvement. You mentioned in your in the chat box that it was due to your colleagues, Jacques, Cyril, and Fana, but clearly you have also conducted the orchestra extremely well. So I must congratulate you and your partners again, Jacques, Cyril, and Fana, the excellent work that they've done in the clear presentations the gains made. There is just a lot to be learned from what you've tried to achieve and the way you've structured this program and with the achievements that have actually been realized. So congratulations to all of you. I look forward to seeing the final results next year. Thanks.
Thank you, Peter. You know, I looked back recently at the first diagram that I did for phase 1, and I remember the feedback that that the diagram helped because, you know, there was a lot of pieces, but the diagram is incredibly complicated. We have actually done everything now that we said we would do on the phase 1. We didn't say that we'd have varieties delivered right on the phase 1, but if we get some of these things to the seed system by the end of the second phase, we're on track. I think a few of the things that we learned along the way that I would really like to highlight, that SMIL enabled that could have gone wrong if it wasn't for the support of SMIL and the EAB, was getting the students to Kansas and having a lot of time with the students, not rushing. So Jacques and Fana understand both worlds, and they're back, and they're not alone. That they were able to plug in, and the project was able to plug in to other people being trained. So this whole cohort of these new breeders, right? Cyril, Ardali, Jacques, Akata, and Nofu, then brought in on the second phase. They had all trained together, and so the vision on the second phase is really the vision that they, in a large part, that they developed, right? It was like the second phase was really a combination of the initial vision from phase 1 with the new vision that was led by this new generation of breeders. And one of the things that's been happening, I wasn't just being humble. I've really stepped back. Really what you've seen is managed by the people who presented it, not just day to day, not just week to week, month to month, over the now almost 2 years since they've been back, since Cyril took over the program, since each of the breeders took over their own programs. This is them.
And what's exciting is that they not only trained together and gotten to know each other and gotten to know the program, they're now actually working together and building that trust and familiarity and the relationships that are the foundation for really effective collaboration going forward in the coming decades. So again, congratulations to the entire team. Well done.
So are there any more questions for the SAWAGEN team? Lots of great comments in the chat box. So every member of that team, please go take a look and take those to heart. And thank you very much for that very comprehensive and presentation. So we're at the end of our day. We are actually 2 minutes ahead of schedule. So wow, I don't know how we did that, but we did. We've had some great conversation today. We've seen some, from my perspective, again, and Jeff, you put it in very nice in terms of how much support the management entity and the external advisory board has provided, but it's been very critical. And the team has taken it in, and boy, I guess maybe it was constructive at the same time. Sure seems that way. And even back to the first two projects of the day, to see how far we've come and the products that are on the cusp of being delivered. Some have already been delivered, of course, in the food products issue. The insight, the public goods, global public goods that have been, that Fauna mentioned, that are released for the world to take advantage of. Wow, you know, those don't come easy. And so I'd like to just leave on this very high note of appreciation for all three presentations today, the presentations that have come before you in the previous days. And I look forward to following up and ending strongly with two more presentations tomorrow by Dr. Persoir and Dr. Mengistu in Haiti Haiti and Ethiopia. Both have two strong products that I'm sure they're going to talk about from the genomics-enabled breeding approach. So I look forward to these two presentations tomorrow. We'll have some closing comments and discussion, and we should adjourn before 11 p.m. Central Time tomorrow. So with that, I'm gonna, Nat, do you have any announcements? Ben, do you have any announcements?
No, we're fine here.
We got that one loud and clear, Nat.
Nice echo.
Nat?
Yeah, just want to say, yeah, I echo a lot of words that were said here at the end. Great presentations, great discussion, accolades to everyone. In the chat, I put a couple items for you just to take a look at. Everything is available on that website that I keep putting up, our SMIL annual meeting website. The Zoom links are there, the passcodes are there. Later on, in a few hours, hopefully I'll be able to get that Zoom link and passcode for today. And also breakout rooms are available. So if you do want to take advantage of those are open now. And so I'll try to keep an eye on that. If anyone is in there, like I said earlier, they do close down about after about 40 minutes of inactivity. So if you aren't going to get in there, well, let me just say it's best to do it now before it shuts down. So, all right, thanks a lot, everybody.
Ben, we have some posters that were submitted. Do you want to tell us a little bit about where they are and kind of the where to go to find those?
That's right. Yeah, yeah. Thanks, Dr. Dalton. Yes, also on that link that I just put in the chat there, the SMIL annual meeting, there are posters there, and you can download those just like you can with any of the presentations. So if you just go there, you can get anything you want there. If there are other posters that you haven't submitted to me, please do so. Just send an email message to me or WhatsApp or whatever works for you, and I'll get those up there.
Great, thank you, Ben. So we didn't have a formal poster session, but certainly there's plenty of background information for you to take a look at your leisure. So great, thank you very much, External Advisory Board. We look forward to seeing you in the breakout room. And everyone else, we look forward to seeing you tomorrow. So have a great rest of your day. Thank you, everybody.
Thank you.
Thank you.
Goodbye, everybody.
Thank you.
Goodbye, Niger. Goodbye, Senegal. Goodbye, Ethiopia. Haiti.
Bye-bye. We'll see the members of the.
Thank you.
Bye, everybody. We'll see the members of the EAB in the EAB breakout room too.